Hello everyone, welcome back to a new tutorial. Today you will learn how to build an MP3 player from scratch using Jetpack Compose MVVM and Clean Architecture with the help of MediaPlayer. The objectives of this tutorial are learn how to do basic operations such as play, pause, seek, stop, etc. using MediaPlayer class. Learn how to build a visualizer using visualizer class. Learn how to retrieve metadata, and a small example with shared preferences. So the application that you will build by the end of this tutorial is going to look like this. So launching the application, and behind the scenes, if we have the permission already being granted by the user, we can retrieve songs from music library. Otherwise, we are not able to, we won't be able to get anything from the music library. So I have just prepared some songs in advance. So right now I don't have any permissions granted, so I'm going to click on this button and the device is going to ask me about the permissions. So allow audio player to access photos, medias and files. I'm going to allow, and allow audio player to record audio. In this tutorial we're not going to record anything, but the visualizer requires record permission in order to perform correctly. So I'm going to press allow. After allowing all the required permissions, I'm going to click again on that button. And I have the list of the media. I'm going to click I'm going to click, for example, the first item. So as you can see here, I have in my device right now, you can see the visualization of waveform in real time. So you can do basic operations, for example, play, pause. I can skip with 5 seconds forward or backward, and I can, for example, like the song. You can see a small animation right there. And I can choose another song. For example, this song doesn't have any embedded picture. I'm going to choose one with an embedded picture. Let's see, for example, let's do space. As you can see here, we have an embedded picture shown to the user. So basically, this is the application that you're going to build by the end of the tutorial. Without further ado, let's jump right in. So first things first, I'm going to update the build.gradle files in order to make my project up to date and to implement, or in order to import needed dependencies. So I'm going to start with build.gradle, and this is my configurations for this project. I think there is a newer version of Compose UI version. The newest is 1.3.2. So this is the first step, and let's move to the module file. I'm going to add here compile SDK 33, and I'm going to switch to 33. This is the configuration for plugins for dependency injection. And let's move to the here in Kotlin compiler extension version. Instead of this hard-coded version, I'm going to do compose version. So the compose version variable is declared here in my Gradle file. So this is the compose version 1.2.0. And those are the dependencies that I'm going to need in this, that we are going to need in this project. So as you can see here, we have Hilt for dependency injection, and we have SharedPreferences library. So the SharedPreferences library is aimed toward saving small data. What I mean with small data that are not complex. In other words, data does not require a relational database. So in our example, we're not going to create a database only to save the favorite songs. So for that matter, I'm going to use SharedPreferences. It's lightweight and it has everything we need. The second library is a splash screen. There is no complete application without a splash screen. And the JSON converter, because we will need this library in order to convert from long lists of long values to string and vice versa, while saving the data using SharedPreferences. So as you can see here, we don't have any other libraries that it's going to read for us MP3 player and retrieve data, metadata, or visualizing the data. Everything is included in Android by default. So once doing that, I'm going to hit sync in order to make my project up to date. So the second step is going to consist of preparing the resource files. What I mean with resources are the launcher icons, the map map. I'm going to delete the default one, and I'm going to override colors, strings, and theme, and I will add the splash screen. So I'm going to delete those files. I'm going to add my own. Delete anyway. So those are my icons. If you don't like the icons that I have prepared for this project, you can add your own. So next I'm going to add the map files or the map icons in order to add them to the manifest. So in order to add the map, first of all, I'm going to choose this IC launcher icon for the foreground, and for the background, I will choose here this background layer. So I'm going to first of all override the colors in order to add the color white. So these are the colors that we will need in this application. I'm gonna come back to the to create the needed map icons, so resources, and I'm going to hit image assets. So this is my icon, or the launcher foreground icon. Let's move back. Let's move to the background layer. So here's the background layer. I'm going to hit next. I'm going to press finish. So I have set everything ready. So let's check the map. We have the icons, and let's override the other files. Let's go to the strings file. I'm going to add here the strings that we will need throughout this project. So these are the strings that we will need throughout this project. You can add your own, there is no problem. And let's change the theme of the application. Basically, we will need a light theme and a dark theme. Let's implement the light theme first. So this is my light theme, and I'm going to create the dark theme. So I'm going to head to resources, and I will do Android resource file. And I'm going to name it themes. And in the folder, the directory name is going to be values night. I'm going to hit OK. And you can, as you can see here, we have two we have two names. We have two files, themes.xml and themes.xml night. So I'm going to override this one. So this is the night theme for my application. Next, I have to create the theming for the splash screen. So in resource file or resource folder, I'm going to create a new Android resource, and I'm gonna call it splash theme. So the splash theme, as usual, it will consist of this. For the color, splash screen background is gonna be this color, and for the splash screen logo, it will be this logo. So I will override the version 23. And what else? For the default splash screen animation duration, I have set it to 4 seconds. Now for the post splash screen, so the theme that's going to be applied after closing the splash screen, it's going to be our whether it's going to be light or dark. And I have just applied the translucent status to my splash screen to my splash theme screen. So I think that's pretty much it. We have ordered colors, splash theme, and strings, and the theming, dark theme and light theme. Let's move back to the manifest.xml. And I'm going to add here the needed permissions. So I will need record audio in order to allow the visualizer to work correctly, and modify audio settings. And I will need read and write external storage. I think this one is optional. And what else? I will need to specify here the theme. So I have set the icon to a rounded one with the same thin icon and the rounded icon. And I have put the request legacy external storage in case of the older versions. I'm going to get rid of this label. And I'm going to specify here the theme of my application. So instead of doing theme.headphone player, I'm going to do theme.app.starting. So we are done with the manifest.xml. Let's override the compose size of the projects. But before doing that, I'm going to add here in the resource folder, I'm going to add the font that I'm going to use in my app. I have chosen Nonito for that purpose. So this is the font that I've chosen. You can choose your own. I'm going to click, first of all, the color file. I'm going to add here the colors that I will need. So these are the colors that I will need, and I have defined the button gradient, so the gradient color to be applied in my play pause button. So I'm going to close color. Let's move to the shape file. Here I'm going to do here 6. I'm going to put 6 and 8 dp. So that's pretty much it. For the typography, I'm going to apply the font that I have chosen for this project. I have named the font Nonito. The biggest font is 30 and the smallest one is 10. So the last one is going to be theme.app. That's KT, so the theme of our application. Let's start with the dark palette or the dark theme colors. I'm going to add here suppress conflicts on colors. So this is my dark theme. You can override the dark theme to your liking. I'm going to override now the light palette or the light theme. And I'm going to add this annotation as well. So that's pretty much it. And here I will, instead of typography, I'm going to add here Nonito typography. So pretty much our theming and the side, the Jetpack Compose side of our project is done. Let's move to the next step. So I think our project is ready to go. I'm going just to get rid of this composables and I'm going to hit. So that's pretty much it. Let's remove the unused imports. The next step, we will configure our dependency injection. So in order to do that, I'm going to create in the root folder or the root package, a new package. I'm going to call it application. And inside the application package, I'm going to add a new Kotlin class. I'm going to call it headphone player application. You can call it whatever you want. And this class is going to inherit from application class. And I will annotate it with Hilt Android application. And I will add here parentheses. And directly, before forgetting the step, I'm going to add the application to my manifest. So Android name and headphone player application. And I will specify the main activity as the main entry points. So Android entry points. So I think our dependency injection is ready to go. So I'm going to transform this project to a clean architecture project. You don't have to follow to the letter the layers of dependency injection of clean architecture. What I mean with that, depending on your project, you can get rid of some layers. In our case, I'm not going to create a remote package because we're not going to use any remote data source. I'm not going to create DTOs. I'm not going to create a lot of layers. I'm going to create only the layers that I will need. So don't follow to there is no one that's going to blame you if you don't actually follow the clean architecture. The most important thing is that you will create your project according to the principle of clean architecture. In our case, I'm going to add here in the root package another package. Of course, we will need a data package. So why, you might ask? I'm going to add here data. The data package is going to consist of the repository implementation. We will have a domain layer, of course, defining the methods that we will need in this project. And we will have to implement the interface of the domain layer inside the data layer in the repository implementation. So we will need actually a data layer here, and we will need another package called repository. The repository package, it will consist of the implementation of the domain layer. Speaking of which, I'm going to add here the domain layer. So domain layer will have the repository, and it will have data, or it will have the model package. So why the model package? Simply, we're going to retrieve the metadata from the MP3 files, and we're going to model this data in a model class, data class. So we won't expose any other information besides the except the model class to the view model in order to work with the principal MVVM. So those are basically our data layer, domain layer. So concerning the presentation layer, the UI layer itself, it is a presentation layer. Anyone is going to understand that the UI means the presentation layer. So you don't have actually to create a presentation package, name is presentation, and force the clean architecture to your project. That's what I mean with not following the clean architecture principle to the letter. So that's what I'm going to do exactly. Just in order to make things cleaner, I'm going to add here in the UI an activity package. Why I have added activity package to my list or in the UI package? Because I don't want my code to get messy, because I'm going to need states in my view model, and I'm going to need again the view model. I will need another class defining the events of my UI. This is just a personal choice. For me, it's not ideal. So I'm going to move this main activity to activity package. I'm going to hit refactor. So inside the activity package, I'm going to put my main view model and defining the states of my activity, as well as the events and other related classes. So I think our project is good to go. So the first objective of this tutorial, I'm going to show you briefly how to make basic operations, such as playing an MP3 file, pausing an MP3 file or an MP3 track, and stopping MP3 track, seek, and so on. So there is nothing much in this media player. I'm going to create here a new class. I'm going to call it main view model. So the main view model is going to be of type Hilt view model. So first of all, I'm going to create here a private var player. It's going to be nullable. It's going to be of type media player, and it will be nullable. All the operations that we will do are included by default in Android. So we don't have actually to add any external library. I've seen some developers using XOPlayer. So I think in our projects, we won't need actually any external library. So first of all, we are declaring the player object. Let's create here a function that's going to init for us the initialize for us the audio. So I'm going to call it init player. So before doing anything, first of all, we have to initialize our player. So by initializing our player, we will assign the media player to the object media player. So we will do here player equal media player, and we will do here apply. By doing apply, we're going to configure the media player object. First of all, we have to set the data source. The data source function, as you can see here, has possible implementation. You can provide the URI. You can provide the path of the MP3 file. You can provide the assets file descriptor if you want to play, for example, some MP3 files included in your application. And you can provide the media data source. So in our tutorial, we will provide the context with the URI of the media player. So the operation is going to be here as context. So we will define here in this function a context object of type context, and we will have to provide here the URI. I'm going to call it URI of type URI. So after setting the data source, we will call the prepare function. So prepare function is going to prepare for us our media player object. We have actually two type of how to prepare your media player, either synchronously or asynchronously. We're going to choose the synchronous method, which is prepare. So our media player is ready to go. By the way, the media player is not only for MP3 files. You can read remote videos as well as remote MP3 files. Not only, of course, the extension of MP3, you can also read another format, depending on your needs. So media player, I think it's a good solution for this purpose. So after initializing the media player, I'm going to create here a function defining for us, for example, the play method. So play method is going to be simply as follow: player, if it's not null, we will do start. So if you call this method in your Composable, you will hear the music playing in the background. Another function. So these are basically the basic methods that you will see in any MP3 player. Pause. With the same thing, if it's not null, we will do pause. Another function is stop. So for the stop method, what you have to do, basically you have to follow the steps. First of all, you have to call player.stop. Afterwards, you have to call the reset function. So when calling the reset function, it will put the media player to an initialized state. An initialized state is the state of player when we didn't call prepare function yet. So this is the main purpose behind calling reset. So after calling reset, you have to initialize again your media player by calling prepare. Afterwards, I will do prepare.release. So release will free any resources, and in the end, I'm going to assign player to null. So this is the correct way to stop your MP3 file. And we can define another function to, let's call it, for example, seek. We will define here to play a certain position, or to position the current position of the media player to a certain position. So we're going to create position. It's going to be integer. So I will do here player. If it's not null, I'm going to do seek position, and millisecond, and position is going to be the position. That's pretty much it. So this is basically the basic operations that you can find in any media player, generally speaking. But this is not enough for our application. We want to visualize in real time the waveform to a composable. So in order to do that, let's go back to the root package. I'm going to add here a new package. I'm going to call it util. Inside the util package, I'm going to create another package. I'm going to call it audio. Here I'm going to gather every classes that I'm going to need or related to the audio operations. Inside the audio package, I'm going to create a new class. I'm going to call it visualizer data. So the visualizer data, it will allow us to resample or to take some samples from an audio file and convert the byte array to an integer or an int array. Just a side note, I got inspired from an article. I'm going to leave the link in the description below to see the original article. I'm going to, I have just made minor changes to that implementation. So this is just a side note to give credit to the owner of the implementation. So the class is going to need in the parameter value raw waveform. It's going to be of type byte array, and let's give it a default value of byte array with the size of 0. All right. So I'm going to use here, name it parameter. Another value that's, or dependency that the visualizer data will need is capture size. It's going to be an integer. I'm going to give it 0. The capture size, what do we mean with capture size? Is the length of capture data that must be of power of 2. This class is going to have only one function called resample. So the resample function is going to convert for us from the byte array that we'll obtain from capturing the waveform, it will take in parameter resolution of type integer, and it will give us an integer array. So what do we mean with the resolution? Simply how many bars we need to represent in our composable. If we want to represent, for example, 32 bars, the resolution is going to be 32. So for each bar, we will calculate the average of a sample. That sample is going to be a group, and we will take the average of that list and we will assign it to the value of that presentation of the resolution. So here I'm going to add a value. So first of all, if the capture size equals 0, we will do here an early return with integer array of 0. So if the capture size is more than 0, so processed, it will be of type integer array. So this is the result of our conversion. So it will be of size resolution. We need a new value called group size. I'm going to call it group size. In group size value, I'm going to define here the size of the resampled data. So it's going to be capture size divided by resolution. So now for each bar represented in our composable, we will get first of all the resampled group, and we're going to calculate the average of the data that's inside that sub list, and we're going to store it for that particular bar. So I'm going to do here for from the index in the range of from 0 until the resolution. We will store in every single bar this value, and the value we're going to get the value from the raw waveform. So the raw waveform in the format of byte array. So for each element, I'm going to take only the positive value. So it's going to be the absolute value of it, and I'm going to convert it to an integer. I'm going to create here just another local value to see what's the type of this process or this conversion. I'm going to call it data. So the data in the type of list of integer, right? So I'm going to come back here, I'm going to add this line. So now we're going to do the resampling operation. So the resampling basically, I'm going to take samples from the array form. It's going to be of type, it's going to be by calling sublist. Sublist is going to give us a list from that parent list. So we have to provide here the index from to. So the index of from, it's going to be the iteration time group size to index. It will be the minimum of these two values. So the first value, it's going to be, so I'm going to import first of all min, and the first value, it's going to be the iteration plus 1 time group size, and the second element, it will be the raw waveform or the size of the raw waveform. So as I said before, it will be the average of this sublist, and I'm going to convert it to integer. Finally, I will return the processed data. So this is the resampling operation or the resampling method that's going to allow us to convert from the byte array raw waveform to integer. And the raw waveform is going to be a data that we will capture in real time from that MP3 file. So I hope you understood the mechanism behind this conversion. So basically we are going to take small samples from that raw waveform, and we will assign each element. So the processed elements, it corresponds to that to data of that single bar inside our composable, and it will be stored inside that data. We will store the average of the sublist. Sublist is the samples, and we're going to convert it to integer. As you can see, we need to define the maximum and the minimum values to be represented in our composable as background. For that purpose, I'm going to create here a companion object for some static methods. I'm going to call here a public static method, get max, or you can call it whatever you want, background processed data. I'm going to call it get max processed data, or get max processed. It will have the same algorithm and the same syntax, int array. And I'm going to create here a value called processed of int array. And the length or the size of this array is going to be resolution, how many bars in our composable. And with the same thing for index in the range 0 until the resolution, we will do processed. It will be of integer. It will be resolution time 4 in order to fill the max presentable data. And finally, I will put here return processed. I'm going to add another function. I'm going to need basically this function when I'm going to create states in our main view model. So defining the empty visualizer data. So empty visualizer data, it will be of type visualizer data, and it will return visualizer data. So now we have defined the resampling method that's going to allow us to have to convert byte array to integer array to be represented in our composable. We need a class that's going to capture the raw waveform in real time. So I'm going to call it visualizer helper. We will implement a method called onDataCaptureListener that's going to give us the ability to capture the raw waveform, or FFT data capture. So in order to do that, we need actually a private field. I'm gonna call it private var visualizer of type visualizer. So the visualizer private member is going to allow us to retrieve the raw waveform in real time. To capture the data, we have to implement, as I said, a method called onDataCaptureListener. So I'm going to create here a function, private function called visualizer callback. By the way, this callback is going to be executed in the main thread. So this method is going to have in parameter a callback function on data. Why do we need on data callback function? We need to store the captured data as a form of visualizer data class in order to expose them to our composable. So it's going to be of type visualizer data unit, and this function is going to return object of type visualizer dot on data capture listener. So we have to implement two members. So we have basically the method on waveform data capture and the method on FFT data capture. The store methods are the methods of capturing the data. You can override the method that you like. In our tutorial, we'll only implement the on waveform data capture. We're not going to focus on FFT data capture. So first of all, the method on a waveform data capture is going to give us 8 bytes unsigned mono samples by calling the get waveform. And the second one is frequency data. So FFT stands for fast Fourier transform. It's an algorithm that computes the discrete Fourier transform of a sequence or its inverse. And it will convert a signal from its original domain to a representable form in the frequency domain and vice versa. So this is basically the algorithm behind the FFT. We're not going to do the FFT implementation. We will do only the waveform. I'm going to change here the parameters instead of P0 and P1. So inside this, what we will do basically in this callback function, or in this on waveform data capture, we will call on data. We have to pass the class visualizer data, and of course we have to provide the raw waveform. The raw waveform is going to be the waveform from the parameter of the function on waveform data capture, and we need to provide the capture size. So what do we mean with the capture size? So the capture size, as I said before, is the length of the data that must be represented. It has to be with the shape or the form of power of 2. How do we get this value? We're going to create here a new companion object. So I'm gonna call here val capture size. It's gonna be constant throughout our projects, equal visualizer dot get capture size range. I'm going to take the first element. So by doing the first element, we will get the minimum of the get capture size range. So here I'm going to do capture size. So by doing on data capture on data, passing the visualizer data as a result, we are going to retrieve the visualizer data. But if we leave the function with this implementation, we will have some problems in capturing the data. What I mean with that, we only need to call this function on data when we have captured the data, or the duration since the last time we have captured the data is more than the animation that we will specify in our composable. I'm going to call this animation duration of the raw waveform. As you have seen in the first part of the video, I'm going to call it const value sampling interval. So the sampling interval will be the duration of the animation that we will present in our composable. I'm going to set it to 100. You can do the value that you like. So if the duration since the last time that we have captured the data is more than, for example, in our case, 100 millisecond, or we have captured the data before, we can execute this function. Otherwise, this function is not going to be executed. So in order to do that, we have to calculate the duration since last time we have captured the data. And I'm going to create here a new value. I'm going to call it now. So now it will store current time millisecond. So system.current time millisecond. And I will calculate the duration since last data capture. I'm going to call it duration since last data. It will be a value that I have, or a variable that I have to create. So here it's going to be duration. So the variable will be here a local variable, last data timestamp. It will represent the amount of milliseconds since the last time we have captured the data. It's going to be long and it's going to be nullable. So if the value or the variable is null, which means that we didn't capture any data. So here I will do last data timestamp, and if it's not null, it will be now minus it, and it refers to the last data timestamp. So this is a nullable value. If it's null, we will assign the value 0 to the duration since last time we have captured the data. So as we said before, we're going to capture the data only if the last data timestamp is null, or duration since last data timestamp is superior than the interval that we have set for the animation. It will be sampling interval. In this condition, we will of course get the captured data. And finally, after capturing the data, we will store the last data timestamp as the current time in milliseconds. So that's pretty much it. For the on FFT data capture, it's not our concern. I'm going to create, for convenience purposes, two methods that are going to start and stop the visualization of the waveform. So the first function is going to be start. So basically, we're going to call this start method in the main view model. After launching the MP3 files, we're going to start capturing the data to represent them in a composable. And when doing, for example, pause, we're going to stop the visualization of the waveform, the same as when calling stop as well. Every time we're going to start and stop the visualizer, we have to release resources, then initialize again the visualizer. So I'm going to create here stop method that will free resources, and we're going to assign the visualizer a null value. So before doing anything, I'm going to call stop to free all the resources, and we will visualize, or we will initialize again the visualizer. So it will be visualizer equal visualizer class, and we have to provide here, so here it's going to be visualizer, and as I said, we have to provide here the information that's going to allow us to visualize the audio or the related audio. So in the parameter, we have to pass in parameter the audio session ID. So I'm going to add here a parameter to this function called audio session ID. It's going to be of type integer. So here I'm going to pass the audio session ID. So basically, the audio session ID, we're going to get this information from the main view model. After preparing the audio player or the media player, we're going to do here session or audio session ID. So we can get the audio session ID from the class media player after initializing the media player. So basically here in this apply block, we're going to launch the method of capturing the data. We're going to launch this method start with the audio session ID. So I'm going to remove this line. I will do here apply to configure the visualizer. So first things first, before doing anything whatsoever, we have to disable the visualizer. So I'm going to do here enable equal false. And I have to set the capture size to the capture size that we have provided in the companion objects. As a reminder, the capture size will consist of the minimum capture size, because as I said, when choosing the first value of the array, it represents the minimum for capturing of the capture size. Good. So afterwards, I have to specify here the callback that it's gonna allow us to capture the data. So it will be set data capture listener, and here I have to provide the callback that I have created, visualizer callback, and I have to set on parameter the I need here on data. So as well, I will with the same, I need here a callback function. I'm gonna call it on data of type visualizer data. It's gonna be void, and I'm going to pass on data here as a parameter, and the second parameter, it will be as I said here, it's gonna be the rate. So the rate, it will be visualizer that gets maximum capture rate, and we're going to specify the method that we have implemented. The question is, did we implement on waveform data capture or on FFT data capture? If we implemented on waveform data capture, going to do here true, otherwise it's going to be false. And with the same thing on FFT data capture, I'm going just to do here true in case you want to implement the other source of data, which is FFT algorithm. And after configuring the visualizer, I will do here enabled equal true. Right now, of course, our visualizer is ready to go. So this is pretty much the implementation of the visualizer class. Almost everything ready to go, but we are missing a very crucial and very important thing, which is how to get the audio files from our local device. So for that purpose, I'm going to create here a new class. I'm going to call it Metadata Helper. So the Metadata Helper, it's going to help me, it's going to help us basically to retrieve the data, or to retrieve the audio files, and especially the MP3 files from our music library, which is the music folder. So in order to do that, we're going to use something called a content resolver. It's a class that's going to help us to select the filtered MP3 files from our music library. So I'm going to create here, I need a cursor of type cursor. It's going to be a private function, or it's going to be a private member called cursor of type cursor. It's going to be a nullable type. You have to import here cursor, and I will create a method. I'm going to call it get cursor data. So this is the method that's going to allow us to retrieve data from the or to retrieve MP3 files from the music library. So basically, how to do that, we're going to do here cursor. So this is just the implementation. There is no reason behind using this implementation, except that this is how to implement it. So we will do cursor, and we need to we need to access the context of our application. So we have set dependency injection, so it will be very easy to inject in constructor qualifier application context. I'm going to name it context of type context. So this is why we have added dependency injection to our projects. So now we have the context. Of course, I forgot here value. So now we have the context. Simply, I'm going to do context.content resolver, and I will specify here the query. So the query is the query of selection. How to select the files from the, for example, the audio, not the audio, but from the media, or you can select videos, or you can select the other related medias. So here I'm going to specify the audio from the external content URI, because we need the MP3 files outside the application inside the music library. So it's going to be media store audio dot media dot external content URI. Now, what's the next parameter? I have to provide the needed data to retrieve. So I'm going to call them projection. Add here a private member. So the projection stands for the data that I need to retrieve from the metadata. So it's going to be an array. I need the media ID, and I need, for example, the display name, duration, title, album, artist. So in order to do that, I'm going to do media store dot audio dot media dot ID. So here is the ID, or the colon of the IDs of the media file. So here it's going to be media store again, media and display name. So the name of the file, audio, that's media, for example, the duration of the media. So duration. Let's say I want the title, for example, of the media. With the same thing, it's going to be media store, audio, media, and as I said, it's going to be title. I'm going to copy this one. Let's say we want the album ID. I'm adding those columns in, just for the sake of this tutorial. Perhaps we don't need those columns. So I'm going to do here, for example, let's say I want artists. You can choose actually a lot of all this available information that you can alter, bitrates, etc. are available for you from the metadata. You can access them. Anyway, I'm going to put here projection as a parameter. Next, we have to provide here in this function the selection clause. What do we mean with selection clause? We need to specify to the content resolver what is the filter to be applied when querying the contents from the media folder. So in my application, I don't need to show the user the default ringtones, for example, on the device. So I have to filter every audio to fit the music criteria. So after projection, I'm going to call here a private var. It's going to be selection. I'm going to call it selection clause. It's of type string. It is nullable, and it will be the music. So here I'm going to do media store dot audio colons, and I'm going to filter is music. So here we have is music, is audiobook, is alarm, is notification, is favorite, blah, blah, blah. So I'm going to choose here is music. And this is, I'm going to put here a parameter or argument. And I'm going to add here an argument. It's going to be selection argument. So selection argument is going to be an array of the value 1 because we have one argument. And I will put here after projection the selection clause and selection argument. We need another parameter. It is the order to set the order of the selection. I'm going to create here another private member order. Let's say we want to order the for example, the name of the MP3 files in an ascending manner. So media store dot audio colons and display name. As I said, I will present it in an ascending manner. So ascending manner, and I will set here the order in the query. So now we have the cursor ready to go. So if the cursor is not null, we will store here, or we will fetch the columns of each element that we will need. So basically in this app, we will need the song ID, content URI, the content, so the song ID, the content URI, the cover image, the song title, and artist and duration. For that matter, I'm going to create in the domain layer a new data class, and I'm gonna call it audio metadata. So as I said, we will need the content URI. What else? The song ID, it's gonna be of type long. The cover image, it's gonna be of type bitmap, it's gonna be nullable. And song title, artist, for example, and duration, it's gonna be integer. It's basically the duration of the MP3 file. I'm going to add here just a function or a companion object that's going to hold for us an empty metadata object. So it's going to be function empty metadata, and it will return. So for the first one, it's going to be the content, so audio metadata, and the content URI, it's going to be URI that's empty. For the song ID, it's going to be 0. And for the cover image, it's going to be null. For the song title, empty string. For the artist, empty string. And duration, 0 as well. So this is defining the empty audio metadata. So those are basically the ID, the data that we will need, that we will model and store in our metadata. So I'm going to move back to the metadata helper. So I'm going to fetch the colon of the song ID. So I'm going to call it ID colon. So it will be the cursor. Of course, I have to create here a parameter. I'm going to call it cursor. So it will be cursor dot get colon index or throw. And since I have the projection ready, I'm going to do here projection dot first to retrieve the colon related to the ID. I will need the duration. So I will do here another space. So it will be with the same thing, cursor dot get colon info index or throw. So the duration, its index is 2. So projection of the index 2. So I'm going to copy 2 of those to access the title and the artist. So I'm going to do here title. I'm going to add here colon to specify it is a colon. So title colon and duration colon. Sorry, here it's not duration colon, but it's artist colon. So with the same thing here, the index here is going to be 3 and the other index, it's going to be 5. You can get rid of the unnecessary columns from the projection. And so once we are storing the columns, we will do Afterwards, we are ready now to get the data from the cursor. So it will be cursor, that's apply. So now we are inside the cursor object, and we will do if count more than 0, then we will fetch the data. So it's simply, we will do here while cursor dot next, or move to next, or create here a value called ID. It will be cursor dot get long, and I have to provide in parameter the colon ID colon. With the same thing, I will do the others. So duration, title, artist, and content URI. So duration and title, artist, content URI. So for the duration, instead of get long, it will be get int with the duration colon. For the title, it will be here title colon, and for the artist, it will be artist colon. So for the title, it's going to be get string, and for the artist, get string as well. So now for the content URI, of course, we have to specify the content URI from the external storage and providing the ID as a reference. Content URIs dot with appended ID, and it will be media store dot audio dot media and external content URI, and we will provide here the ID as a reference. So this is the content URI, and I will specify here the type. It's going to be of type URI. Let's import URI. So now we are storing the information. Let's create here in the function a value. It's going to be the audio list that we have retrieved. So audio list, it will be mutable list of, and here the data or the type, it will be audio metadata. Make sure to import the correct one for the domain layer. After declaring all the values, I'm going to add here the audio list. I'm going to construct the list as follow. So audio metadata, and for the first parameter, it is song ID. It will be the song ID. For the content URI, it will be the content URI. So for the cover image, it's going to be constructed on demand. So I'm going to do here null. Why I've chosen to be constructed on demand? In order not to make this function very slow. So it's going to be, imagine that you have 100 MP3 files to scan. It's going to be very time consuming. So I'm going to do it on demand. And song title, it will be the title. For the artist, and duration. Finally, the last instruction should be, we'll return here the audio list, and I will change the function syntax declaration to list of, or let's say here, not list of, but mutable list of audio metadata. So this is how to retrieve the audio metadata from the, while using, of course, the content resolver. I'm going to create here a public function, just for convenience purposes. I'm going to name it get audios. This public function is going to give us the same thing, but it will be the list of audio metadata, and it will return the get audio or get cursor data. This function is going to take some time to finish, so I have to annotate this function with worker thread, indicating that this function should be only called when inside a worker thread context. It's going to be like a suspending function. So now we have the list of metadata, or the list of MP3 files. I'm going to add one last function that's going to retrieve the cover, because we have retrieved the song ID, content URI, the title, artist, duration. But what about the cover image? The cover image, as I said, it's going to be on demand. So I'm going to create for it a dedicated function So it's gonna be public function. I'm gonna name it, you can name it whatever you like. It's gonna be called getAlbumArt. So this function is going to give us, in the end, a bitmap, a nullable bitmap. So how we can retrieve the embedded image? We can retrieve the embedded image using the class media metadata retriever. So I'm going to call here media metadata retriever. It will be of type media metadata retriever. So it's very simple. First of all, you have to set the data source as we have done in the audio library. So metadata retriever set data source, and we will set, or we can retrieve the data source or the MP3 file using the context and the URI. So I'm going to call here context of type context and a URI of type URI. We have, of course, the context in our application. And here inside the set data source, I will do context and URI. And afterwards, you will get the embedded image by doing metadata retriever dot embedded picture. So that's the simplest implementation for it. But we're going to add some minor changes to that implementation in order to have an efficient implementation. So first of all, I'm going to call here a value. It's going to be called bitmap of type bitmap. It's going to be nullable. It's the result of our function. So I'm going to do it in one single line. So the method or the instruction metadata retriever dot embedded picture is going to raise an exception. So I'm going to show you what is the exception. Embedded picture. So the embedded picture, of course, it's a getter, and the getter is going to throw a runtime exception. So that's why I have surrounded this block with try catch. So I will do here try catch and exception of type exception. So first of all, I have to get the data, which is the embedded picture. I'm gonna call it data. So it will be MMR, that's embedded picture. Nice. So if the data is not null, because it's gonna give us empty data, because not every MP3 does have an embedded picture, as you have seen in the first of the video. So if it's not null, then we will decode this embedded picture. Otherwise, we will return null. And if we have an exception, we will return null as well. In the case we have the data, to convert the data, because the embedded picture of type byte array. So in order to decode from byte array to bitmap, we will use the bitmap factory dot decode byte array, and in parameter I will put here data 0 and data size. So as a best practice, you have to release all the unnecessary resources when you are done converting or getting the embedded picture. So I'm going to add here a final or finally clause. So whether we have an exception or not, we're going to release the, or we have to free the resources by calling mmr.release. In the end, we will do here return bitmap, the results of the conversion. And this method also is going to need some time to finish, or need to be called in a worker thread. So I'm going to annotate it with the annotation worker thread. So that's pretty much it for the implementation of a metadata helper. So this is basically how to retrieve metadata from, of course, media file, and how to retrieve the embedded picture using the metadata retriever. So I think we are done implementing basically the basics or the needed classes in order to make our application running. I'm going to move to the repository under the domain layer in order to add the interface defining the list of methods that we will need in this first section of this tutorial. So I'm gonna call it headphone player and repository. It's gonna be an interface. So the two methods that we will need for now are the get album art and get audios. So I'm going to take this header of the function. I'm gonna paste it here, and it's a worker thread, so it's gonna be a suspending function. We do the same thing for the get album art. You can add a description if you want to this two methods, but it's not necessary for now. So what I mean with description, just you can add here some kind of small documentation for your function, but you can do it afterwards. So those are the two methods that we will need. Next step, we will now implement those methods in our repository under data layer. So I'm going to create here, I'm going to copy this one, and I'm going to create a class called repository implementation. So the repository implementation is going to implement the interface headphone repository, and it has two members. So as a dependency, I will need here the metadata helper. So I'm going to inject in constructor. It's going to be private val metadata helper. So for the first method, which is get audios, we have to call this function of get audios in a context of coroutine. So it will be returned. So with the context, and I'm going to provide here dispatcher or dispatchers that input output. It will be metadata helper that gets audios. Simple as that. With the same thing, so it will return with context and dispatchers that input output and metadata helper that gets album art, and I will specify here the context. It's going to be context, and the URI, it will be URI. So that's pretty much it. So let's just verify if we didn't forget anything from the visualizer. So I think the visualizer looks fine. Let's move back to the visualizer data. Okay, a visualizer helper. So, okay, and we captured the data. And okay, instead of waveform, I'm going to clone this, this value, and I will make this audio session ID as an optional parameter. So I think that's pretty much it. And for the metadata helper, I don't think that we forgot anything. So if our application failed to retrieve something, we're going to correct that initially or accordingly. So in the repository implementation, I think that's pretty much it. Now we have to show to Hilt how to provide the needed dependencies. So for that matter, I'm going to create a new package. I'm going to call it DI. So it's going to be DI package. And here I'm going to put a new way to provide dependencies. So I'm going to use another term called binding dependencies. So I will create here an abstract class. I'm going to call it repository module. Why I've called this class repository module? Because we don't need actually any API or database. The only thing that we will need here is just how to provide the repository as a binding. So it's going to be an abstract class, and I will annotate it with module because it is a module, and we will install in dependencies in the parent class, which is singleton components. So singleton component class, and we have only one binding to show how to provide it, which is the repository interface. whenever we are dealing with interface, we have Hilt doesn't know, or interface or a third-party library. We need to show Hilt how to provide the dependency. So instead of doing provides, I'm going to show you a new way, which is how to bind the dependencies. Of course, in the next tutorial, I think it's gonna be the concern of the Hilt dependency injection. I'm going to explain everything in detail about Hilt and the dependency injection using Hilt. So it's going to be an abstract function, and instead of doing provide, I'm going to do here bind. What is the binding? It's going to be the repository. So bind headphone. In order not to miss the spelling, I will do here bind headphone repository, and it's gonna give us the interface. Good. Going to import the interface, and in parameter it will be the repository of type repository implementation. I'm going to add here implementation, and I will annotate this function with binds, and I'm going to annotate it with a singleton to live throughout the life cycle of our application. So that's pretty much it. Now we have shown Hilt how to provide the dependencies. Our view model is ready to go. So let's move back to the main view model, and let's get rid of those functions, or let's just get only rid of the implementation. We need those functions anyway. We will need here the private val repository. It's gonna be repository interface. So we have provided the repository. First thing that we want to do in this, while launching, for example, our application, as you have seen, we have to load the medias. So during init function, I'm going to call, for example, load medias during the initialization of my view or our view model. Creates a function load medias, and it's going to be, of course, a private function. Of course, the operation of loading the medias is going to be from the repository. So I will surround this block with a coroutine scope, and I will need, of course, a parameter or an observable to handle my the loading state. So it's going to be mutable state flow is loading. It's going to be Boolean, and it will be false. So I'm going to import mutable state flow. So at first I will do here is loading that value equal true, and I'm going to create here a local value or local list. It will be of type mutable list of, and the data is the audio metadata. Make sure to import the domain layer class, not the Android.media. And after calling that, after doing that, I will do here audios that add or add all. I'm going to add now the call of the function, the results of calling the function repository that gets audios. Now we have the audios, and I will create here another observable, mutable state flow. It's gonna be called audios of type list of audio metadata, and it's gonna be empty list. And here I will do audios value equal audios. Okay, I think I have to change this to something else. So I'm gonna name it to audios list or something like that. So it's gonna be here audios, and I think that's pretty much it. So now we have loaded the audios, and finally I will do here is loading dot value equal false. So now we have loaded the list of medias. We can retrieve, we can show the list to the user. Once selecting an MP3 file, we can launch or we can play the MP3 file. Great. So now we have the medias ready to go, but just for convenience purposes, in order to represent the artist, because for example, we can have the label unknown in the artist. In order to make a better representation in my Composable, I'm going to create here a private suspending function in order to update the from the unknown presentation to, let's say, for example, add the string unknown artist. So it's going to be here a private suspending function. I'm going to call it prepare audios. It will give me a list audio metadata. So it will return repository that gets audios, and for each element I will create here an artist value. It will be as follow. If the element which is an audio, I'm going to add here audio. If audio that's artist contains the keyword unknown, the artist will be let's say, for example, unknown artist. All right. Otherwise, it will be audio.artist. And afterwards, I will do here audio.copy. And I will provide the artist with the new presentation of the artist. And here, instead of doing get audios, I will do prepare audios instead. So now we have loaded the medias, we have prepared our audios. Now we are ready to launch to initialize the media player. So inside the initialize audio, what we will do here, we will pass in parameter instead of context. So I'm going to change a little bit the header of this function. So as you can see in the first of the video, we are going to select an audio file. Then we will play that audio file. So we will need an audio file as a parameter. So audio metadata and a context of type context. So we will launch accordion scope and we will enter the loading state. And in the end, it will be loading.value equal false. So just for convenient purposes, I'm going to add here a delay of, let's say, 800 milliseconds in order to show the progress indicator a little bit because this operation is fast. And after the delay, I will call the cover to get the embedded picture by doing repository.load. Okay, I called it get album art. I'm going to rename this function. Okay, where is the repository? I will do here, instead of get album art, I'm going to name it load cover bitmap. So here it's going to be load cover bitmap, and I will provide as a context equal context, and I will provide the URI as URI. So I'm going to declare here a new state. It's going to be the selected audio. It's going to be mutable state flow selected audio. It will be of type audio metadata, and it's going to be audio metadata, empty audio metadata. Before moving forward, if you have noticed, dear developers, we have too much state to deal with. So we have for now 3 states, and we didn't even finish the rest of the application. So imagine we have another 3 states by the end of this tutorial, and inside the main activity, in order to observe those states, we have to create another 6 variables or values in order to observe those states. So this is not ideal. I'm going to show you a new way to handle this with a very elegant way, which is modeling the states inside a data class called stateholder. So that's what I'm going to do. I'm going to create here in activity a new data class. I'm going to call it audio player state. So it's going to be a data class. The first state, okay, the state that we will need, let's just get rid of the states that we have declared here, is loading an audios list and selected audios. So for the first one, it's going to be is loading. It's going to be of type Boolean, and it will be false by default. Audios, it's going to be list of audio metadata, by default empty list, and we will need, of course, val selected ID or selected audio. It's going to be of type audio metadata. By default, it's going to be audio MC metadata, and we will add the rest of observables accordingly. So instead of doing this mess, what I'm gonna call a mess, I will do instead, gonna do here private var state by mutable. So mutable state of, and the value, it will be audio player state with an empty state. And for the getter, it will be state of type audio player state, and getter equal the state. And instead of doing loading here, it will be state equal state.copy is loading equal true. So you can do that, or you can, instead of doing this kind of syntax, I'm going to change it to something else. Val private, so private val state, it will be mutable state flow, and the value equal empty state or audio player state. And for the getter, which is value state, it will be state as state flow. And instead of doing this kind of syntax, I will do state.update. I will do here it.copy and is loading equal true. And in the end, I will do here is loading equal false. So this is a better way to represent the states in one placeholder or one stateholder called audio player state. So instead of doing audio.value, I'm going to do the same thing, state.update and it.copy and audios equal now the audio, which is the audios. And we can do the same, can add them in the same line, which is just like this. And I'm going to get rid of the loading state. So that's pretty much it for the loading medias. So I think that our code looks better now. We don't have any states. And of course, in the main activity, we will add only here one observable, which is the state with the public accessor. So we have we are now on the init player. First of all, we have to initialize the player. So instead of doing that, I will do here state.update it.copy mutable. You can use the previous way or this way. There is no problem. It's almost the same. So it's gonna be so instead of using state flow, you can use just mutable state. It's your choice. So is loading equal false or true, and the last instruction will be is loading equal false. So now we have selected audio, and instead of it will be selected audio will be the audio from the parameter, and we will copy its copy, and we will access here the cover image. We'll assign it to cover image. So that's pretty much it. Now we have the cover image. We have updated the selected audio with the new cover image. We can, of course, initialize our player by doing MediaPlayer apply So we will set the data source, context, and now how we can retrieve the URI, simply audio.content URI, and we will call the prepare function. Now our audio is ready to go. Now we have to, of course, we have to implement the play method. In order to distinguish between the audio is being played and the audio is not being played, we're going to introduce a new state. Here it's going to be called is playing. So inside the state, audio state, I'm going to add here another value. It's going to be called is playing. It's going to be boolean equal false by default. So here I will do state dot update it dot copy is playing equal true. So now we are playing the audio. Next we will call the method play or start, and as we said before, we need to capture the waveform in real time. So how to do that? Simply we will do player, and if it's not null, we will do the run function. Of course, run function is a scope function. It's not related to MediaPlayer library. So here, of course, we need to capture the data. So in order to capture the data, I will need in my class or my view model a visualizer helper private member. I'm going to add here var visualizer helper. It will be visualizer helper. So I'm going to space the instructions with a space. So after starting the player, and now our visualizer helper is ready to be initialized or ready to be called by doing visualizer.start to start the capturing the raw waveform from the audio. And we have to specify here the audio session ID, and we are now inside the player object. We have the audio session ID, and we're going to call the method on data to pass the data as a parameter. So on data, and I will add here another state that's going to store the data captured by the visualizer. So here I will add another. So here is the question. I think I don't know if it's me or the performance of Kotlin, but when I have added the visualizer data to the list of the player states, the visualizer keep lagging and the visualizer keep skipping frames. And when I have decided to do its dedicated state, the frame rate of the visualizer is a little bit fluid. So that's why I have done here a visualizer with its separate flow or separate states. It's going to be mutable state. I'm going to call it visualizer data, and it will be of type visualizer data, and it will be as initial state visualizer data dot empty visualizer data. And I think that's pretty much it. Let's import this class and state. So I'm going to do here visualizer data dot value equal data. So now we have the raw waveform to be represented in a composable, and that's pretty much it for the play function. For the pause function, as we did before, we're going to do here, instead of playing state, it will be pause state. So the audio is no longer being played, and we will stop the visualizer. So it's my best practice. I always indicate with underscore the private members with underscore. You can do your own representation. So, and afterwards, I'm going to pause the playback. Good. So for the other method, which is stop, it will be, first of all, I'm going to stop the visualizer. Afterwards, I will do, as I said, stop method. Next, I have to reset the state to an initialized state with the reset function. Then I will call player dot release, and I will set the player to a null value. And before doing that, in between, I'm going just to do here state.update. The playback is no longer being played, so I'm going to put here is playing equal false. And for the seek method is pretty self-explanatory, so it's gonna be player, and I'm going to do here run, and I will do here seek to the position will be position, and of course I'm going to change here the position from integer to float, because in the slider it's gonna give us float values instead of integer. I'm going to cast it to integer. So I think that's our view model is ready to go. If we need other functions, we will do them accordingly. But before doing that, I want just to share with you guys a very good practice. You can just leave the functions here as public, the public functions, for example, play, pause, stop, and seek. Or you can model, again, the functions in a sealed class, and the sealed class is going to consist of the events needed in the composable. Because as you can notice here, the for example, in its player, play, stop, pause, stop, seek are events being called in or can be called in the composable. So that's why we're going to put them as a private functions, and in the view model or in the composable, we're going to need only one function, which is a public function declared in the main view model as an event, and we can pass as a parameter the needed events. So I'm going to proceed this way. I recommend you learn this approach, and you can choose your own approach afterwards. So I will do here, instead of this approach, I'm going to add here a sealed class. I'm going to call it, instead of audio player state, it's going to be audio player event. So the audio player event, it's going to be a sealed class defining the hierarchies of my events. So the first event, which is pretty obvious, which is initialize audio. So the functions that they need parameters are represented by data class or modeled by data class, and the functions that you don't require parameters, they are represented by objects. So the first one, which is data class, init audio. So I'm going to copy the syntax from here. So instead of init player, I'm going to call it init audio. It's better this way because we are initializing the audio, not the player. And I'm going to paste this syntax. And instead of doing this, I will introduce the value. So it's going to be value and of audio player event type. So this is the function. Now let's move to the other one, which is we have done here. We will need load medias. Let's get rid of functions requiring parameters. So let's do, for example, seek. So data class seek. It will have in parameter position of type float, and it is audio player events. Let's model the other one, which are play, pause, stop. So it's going to be object play audio player events. I'm going to duplicate this line, and it's going to be pretty much the same, pause and stop. So how to use them in, okay, we forgot just one, which is load medias. I'm going to duplicate this one. So load medias. So how to do that in the context of our view model. So as a best practice, you leave or you put the private methods at the bottom of the file. So here I'm going to put at the top my only public function that's going to be exposed to the main activity. It's going to be called function on event. So on event will take in parameter an event to be of type audio player event, and according to each event I'm going to call a function. So it will be event. I'm going to add all remaining branches. I'm going to move this one here, separate them by line. And let's start with the first one, which is init audio. So in init audio, I'm going to do here init audio. I'm going to provide the parameters. So the parameter, which is context, it will be event, that's context. And for the audio, it will be event, that's audio. For the seek method, it's simple. It's going to be seek and position equal event dot position. You can notice it's pretty simple to load or to implement those methods. So pause, and in the main activity, you won't have to worry about the name or anything else. You can access the events by calling event dot the event that you want to call. So instead, it's going to be stop. So I think that our view model is ready to go. Now let's move to the next section, which is the main activity. So first things first, I need an instance of my view model. So after super on create, I'm going to do here main view model by view models, and it's going to be of type main view model. We need a splash screen, so I'm going to, before calling syscontent, I'm going to configure my splash screen, install splash screen, that's apply. As you can notice, we leave the scope function apply just for configuration purposes. So set keep on screen condition. So just before moving forward, I'm just going to change the syntax or the declaration of the state or mutable state flow in order to be accessible outside my composable. I'm going to do here, instead of doing that, I'm going to rewrite the whole code again. It will be a private state. So it's going to be by, so mutable state of, I'm going to import mutable state of, and the state, it's going to be of type audio player state, and getter, it will be the state. So I have a lot of work to do. So I'm going to do here, instead of state, it's going to be, instead of update, I will do state.copy, and I will provide the needed data. So here it's going to be, of course, state, and it's going to be a variable, not a value. Let's get rid of the unused imports. And so that's pretty much it. I'm going to delete here, copy, and what is it? It's going to be state, that's copy, right? So here I think that we are missing something. So here again, it will be state, that's copy without curly braces. So instead of doing that, I will do here selected audio, and here it's gonna be equal state without curly braces. So for is playing, okay, I'm always missing that. State equal state, that's copy, is playing equal true, not is loading. I'm always doing this mistake. I don't know why. So pause, it's gonna be here is playing false, and with the same thing here, equal false. So let's revise our code. So here we have is playing equal true. In the end, not is playing is loading equal true. In the end is loading equal false. And prepare audios. And what else? For the load medias, we have the right. So we have is loading equal true, is loading equal false, and we have the audios. So here we have is loading equal true, is loading, okay, is loading equal false, playing equal false. Let's go back to the main activity. Sit on screen, keep on screen condition. It's gonna be main view model dot state dot is loading. So after loading the splash screen, we will set the content of our application. So we will build the following layout. So according to the screen, I will need a bottom sheet, model bottom sheet, in order when clicking on that button, I will show the list of audio files. And inside we will have the content of the audio files. and the screen is going to have a top bar with embedded image, visualizer, and slider with the current position and the duration, backward button, and the forward button, and play button. So let's start with building the model sheet. So here after headphone player, I'm going to do model bottom sheet layout. I'll provide here the content and the sheet content. So first of all, I'm going to provide here the sheet content and the content itself. So I have to provide here the sheet state. So I'm gonna call here sheet state, and I'm going to create here a value after set content. It's gonna be called sheet state equal, remember, model sheet state. For the initial value, so whether is hidden or shown, so initial value, it's gonna be model bottom sheet. I'm going to choose here hidden by default, and I'm going to provide skip half expanded. If we have a long list, it will skip the half of the sheet's content. So I'm going to opt for it because it's experimental. I'm going to add here sheet state. So for the sheet content, it will consist of a colon, and I'm going to give it a modifier of type modifier. It's going to fill the max size, and it will be scrollable. So it will be hit here enter, scroll state. So state, it will be remember vertical, remember scroll state. I'm going to add a padding. So for the top, in order to give some space for the title of sheet content, and that's pretty much it. So we're going to show an image if we fail to load the audios from the music folder, or if the user doesn't have any audio files. So it's gonna be if audio, or again, I have to create here another value. It's gonna be called state equal main view model dot state dot. So here if state, so I need audios is empty, I'm going to show an error message to the user. Otherwise, I'm going to show the list of audios. So for the first condition, I'm going to surround that block, or I'm going to surround the error message with a box. So it is a modifier. So modifier equal modifier that's fill max. Here we're going to need fill max size, and content alignment dot center. So I will code here an error message. So inside the UI package, I'm going to add here a new package. I'm going to call it component. Inside the component package, I'm going to create a new composable. I'm going to call it a warning message. So the warning message, it will be a colon, and I'm going to assign a modifier equal modifier fill max width. So with a fraction of 0.9, and the horizontal alignment, it's going to be alignment that's center horizontally. So the first element, it's going to be an icon. So I'm going to import icon, and the painter, it will be painter resource ID. I'm going to provide here, it's going to be a reusable composable. So I'm going to call it icon resource ID. Going to create the values or the needed parameters by the end of this composable. And for the tint color, it will be material theme dot colors. Let's do here on surface. And for the content alignment or the content description, an empty content description. It's going to be, of course, the second composable. For the modifier, I'm going to copy this one in order not to waste time. And for the modifier, I will do here fill max width without a fraction. And I will add a vertical alignment instead of horizontal. vertical alignment, it will be alignment that's center vertically, and the horizontal arrangement that's center. I'm going to add here a padding, so vertical padding, it will be 8 dp. So we have a main text, it's gonna be called text, and a trailing content. Let's give the flexibility to the developer if the developer needs to add extra content to the end of the text. So first main content, it's gonna be a text. So the text is gonna be called text with a text as a parameter. So for the decoration of the text, the color, it will be material theme dot colors dot on surface, and the style, it will be material theme dot typography dot subtitle 2, and I will add here trailing content as an optional parameter or an optional composable. It's going to be invoke. All right, it's going to be nullable. So I'm going to add accordingly this. All right, so for the padding, I just want to make sure that the padding is set correctly. So the padding is going to be applied between, okay, at the top. So that's good, I think. We can do here, instead of vertical, I'm going to do here top 8 dp. I think that's pretty much it. And for the parameters, I will need here a text of type string. You can add, of course, a resource ID, no problem. So for the drawable or icon resource ID, it's gonna be called icon resource ID of type integer. And what else? Let's make this modifier reusable, first optional parameter. And the trailing content, it's going to be an optional composable. Instead of doing modifier like this, let's do here modifier. So this is the warning message. Let's come back to the main activity. And here I'm going to set the warning message. I'm going to do here warning message. And for the text, it's going to be, all right. So text is going to be string resource, that's string. Let's import the R object. And I will add here the content of my string, which is no media. Okay, I think it's okay. So as a reminder, the text, it seems there is no MP3 files in your music folder. You can add your own customized text. And I will put here the icon resource ID. It will be r.drawable. I'm going to do info solid or circle info solid. And finally, the modifier, I'm going to add here a modifier dot padding vertically, can apply here 16 dp. So if we have the list ready to go, or the list is not empty, and keep in mind we are inside a colon, I'm going to add here in the center of the colon a text, for example, track or something like that. So it's going to be row. So I'm going to copy row from here. So we are now inside else. So it's going to be row. For the modifier, it's going to, of course, going to fill the max width with no padding, and only going to do horizontal arrangements to put the element in the center. And for the content of the row, it's going to be a text, and I will put the text here. So import text. For the text, it will be string resource r dot, let's say, yeah, label track, I think, if I can remember, label tracks. For the decoration, font weight, it's gonna be bold. For the style, it will be material theme dot h3. So for the modifier, I'm going to add some padding bottom and top. So for the modifier, it's going to be modifier that's padding. So as I said, top, let's do, for example, 3 dp or 12 dp for the top, and for the bottom, let's do, for example, 3 dp because we have enough space. And for text decoration, I'm going to add an underline decoration. For the color, it will be material theme. Keep in mind we are theming for both, or we are aiming for both dark theme and light theme. So on background, so this is the text underneath. So after row, we will put here state. We'll access the loaded audios, and I'm going to do here. So for each audio, I'm going to call it here an audio. I will represent this audio with a composable. So the composable, I'm gonna call it track, and I will provide here in parameter the audio, and I will present the track as follow. Okay, first of all, I'm going to create the composable. So it's gonna be in components package, gonna be called track. Gonna copy this row again. I'm too lazy to do it. So it's going to consist of a row, and it's clickable row. So it's gonna fill the max size, and it's gonna be a clickable row. So I'm going to put here clickable, because I want to perform an action when clicking on the entire row. So I'm gonna call this function onClick, and I will identify or pass in a parameter an audio, which is the selected audio. So for the vertical alignment, I'm going to align it center vertically, and for the horizontal arrangement, I'm going to do here arrangement space between. So I'm going to group the icon as well as the title and the artist in a single component. It's gonna be row. I'm gonna add here a modifier. It will be a modifier dot fill max height, and here instead of a normal modifier, I'm going to do a modifier that I will declare in my composable to make our composable reusable. So it's going to be a modifier of type modifier with the default value of modifier. So I have to delete here dot, and I'm going to align elements. So vertical alignment, it's going to be alignment center vertically. All right, so the first element in this row, it's going to be an image. I'm going to import image. So here it will be painter equal painter resource ID. I'm going to choose our drawable. Okay, I have to import R first. The content description is going to be an empty string. I'm gonna add here a modifier for the image, create some space between this image and the title, as well as the artist. So it will be modifier dot size. I'm going to specify here the size of the image. I'm gonna give it 60 dp, padding all equal 5. All right, so and I'm going to specify here the content scale dot crop. So this is the first item. The second item, it will be represented by a colon, and I'm going to add vertical arrangement to arrange elements in the center of the column, and I'm going to add a modifier equal modifier with fill max height, and I will add a padding to start of the elements with the value of 10 dp. So inside the column we will have two texts. So the first one, it's gonna be for the song title. So I'm going to pass here in parameter an audio parameter of type audio metadata. It's gonna be the selected audio. So it's gonna be audio dot song title. So I'm gonna add here a modifier equal, and I'm going to specify just a small padding at the bottom of this item. So bottom equal 3 dp with a modifier again. I'm tripping, man. So font weight of the text is gonna be bold. What else? Perhaps the text is gonna be big, or the title of the song is gonna be a long title. So I'm going to add here overflow. It's gonna be text overflow ellipsis, and here color. I'm going to specify if this is the selected track, I'm going to give it a color. Otherwise, it's gonna be another color, which is primary. So I'm going to add here a parameter to specify whether it is the selected track or not. So is plain. So if it's the plain track, it's going to be Boolean. I'm going to specify to highlight this text. So if it's plain, it will be material theme, that's colors, that's primary. Otherwise, it will be material theme, that's colors, that's on background. All right. So I think that's pretty much it for the text of the title. With the same thing here, I will do. I'm going to copy this here, and instead of text audio.song, it will be artist. And what else? And with the same thing for the color, and the font is going to be just a normal font. So this is the first element, and the second element, it will be the icon representing the visualizer. So if it's plain, it's going to be visible only if this song is the played song. So this is the selected song. So icon, and here it will be painter, and content description. So for the painter, it will be painter resource, r.drawable, that's I think it's okay, short, simple, solid, content description, empty string, and the tint. So it will be material theme, that colors, that's primary variant, and I will add a modifier to this icon in order to give a space between this icon and the edge of the row. So it is, I'm gonna give it padding and equal 8 dp. So this is the first. This is the first element. Okay, this is the row. This is the first element, and this is the second element if it's highlighted. So I will need here a callback function. I'm gonna call it onClick. I'm gonna pass here a parameter of type audio metadata without a return type. So this is our composable, or the track composable. Let's come back to the main activity. So here for the audio, it will be audio. For is playing, so it's simple. If the audio dot id equal state dot selected audio dot song id, which means that it's the selected song, or the song that's being played. And I'm going to add here a modifier of type modifier, and then we'll add a padding horizontal. I'm gonna give it, for example, 8 dp, and vertical 10 dp, and I will give here the width of these elements required. I'm going to give the required height. Let's just do here 100 dp will do. The last parameter, which is onClick, what's going to be applied once clicking on this particular track. So what's happened when clicking on this item, we have to close the model bottom sheets. So in order to close the bottom sheet, we need here a scope. So it's going to be a val scope. It's going to be a coroutine scope. So I will launch here a coroutine scope. It's going to be scope.launch. So first of all, we have to stop any track that's being played. So I'm going to do here main view model, that's here on events, and the event will be audio player events. That's stop. So we have to stop the audio that's being played, if there is any, and we will close the bottom sheet, and we will initialize our audio. So it will be on events, audio player, events, and here in its audio. For the selected audio, it will be the parameter it. For the context, I'm going to declare here a variable or a value called context. It will be local context.current. After initializing the audio, we have to call play. So in order to make this function efficient, I'm going to add here a callback function. So after initializing the audio, I will add here a callback function. It will be on audio initialized. So on audio initialized, after initializing the audio, we will call play with us parameter and unit. So let's come back to the main view model. I'm going to add here in this in its audio. So I'm going to copy this name on audio initialized. So where we have to call on audio initialized, we have to call the audio on audio initialized when we have prepared our media player. So there is a listener available for us for that matter. It's called set on. So this is the list of listeners available on the player object. So it will be set on prepare listener. Set on prepared listener. It will be called when the prepare method is done preparing the media player object. So it will be here on audio initialized. Great. So let's add here the parameter on audio initialized. It will be event that's on audio initialized. Let's come back to the main activity, and after this parameter context, we will add on audio initialized. So it will be main view model dot on event, and the event simply is gonna be audio player event dot play. The play method is going to be called only if the audio is done being prepared. So after the track, I'm going to add here a divider, gonna be modifier. Going to add here a padding for the divider with horizontal padding equal, let's do here 8 dp for example, 8 dp. I think that we are done with the content of our model sheets. So this is the content of model sheets. If we have audios, we will show the list of the audios. Otherwise, we will show a warning message. There is no music in your music folder. So now we have to implement content of our page. What I want to do here before doing anything, I will add a dialog showing the progress indicator. As you can see here, I'm going to represent the progress indicator with a dialog. I'm going to call it loading dialog. So I'm going to create here a new composable. I'm going to call it loading dialog. So to create a dialog in your Jetpack Compose, or to create a dialog in Jetpack Compose, we have a dialog composable, and I'm going to make it as reusable components. So after using the dialog, we have to specify the method that's going to be called when dismissing or closing the dialog. I'm going to call it here on done. So what's going to be called, or what's going to be executed after closing the dialog. And I will specify here the properties of the dialog and the content of the dialog. So simply the content of the dialog, it's going to be a circular progress indicator, and I'm going to wrap it with a box. And for the box, it will be a modifier of type modifier. Okay, instead of doing modifier, I'm going to add here a modifier as a parameter to make it reusable. On the content alignment, I'm going to center the element, which is the progress indicator, in the center. And I will add here for the progress indicator a padding all equal 26. So I'm going to import dp. So this is our composable, and we're going to call, or we're going to show this composable only if we are in a loading state. So I'm going to call here another state, or another state can be called on loading. State is loading, and if it's loading, I'm going to show the composable. Otherwise, we're not going to show anything. So right now I'm going to add my parameters. First parameter is going to be on loading, or is loading. It's a Boolean. So the method is going to be called whenever we are done loading. It's going to be on done. You can call it whatever you like, on loaded or something like that. So modifier is going to be an optional parameter to make this composable reusable. Next, we will specify the properties of this dialog. So the properties will be dialog properties of type dialog properties. It will be dialog properties. So I'm going to specify here. So first of all, I'm going to assign the value to properties. So what are the available properties? So for example, if we are going to allow on dismiss back press, so dismiss back press by default, I'm going to make it false. We're going to allow dismiss on click outside. I'm going to give it, for example, false. So for the first one, if we press the back press, will the dialog be closed or not? And the second one, if we click click outside the composable dialog, will the dialog be closed or not? And for the security policy, I'm going to do is security policy inherit. I have never used honestly this parameter, just going to add it for reusability purposes, and use platform default width and use or decor fit system true. So those are basically the properties. This is an experimental, I think, so I have to add experimental to my composable. So this is my dialog for the content of our page. I'm going to add here the dialog. It's going to be shown whenever we are entering the load-in state. So load-in dialog. So for is loading, it's going to be state that is loading. And for the method onDone, we're going to close the dialog when the state is loading equal false. So to do that, I'm going to head to main view model. Or before heading toward view model, I'm going to, So here I'm going to add a new private function. I'm going to call it hide loading dialog. So simply it will be state equal state copy is loading equal false. And I will add this to the object or the list of my methods in the audio player events. So objects here capitalized, and it will be audio player events. Let's come back to the main view model, and here I'm going to add this method player events dot hide loading dialog. It will be hide loading dialog. So as you can see here, our code is more readable than before. So here on done, I will do main view model and on event, and the event will be audio player events dot hide loading dialog. And here I'm going to add a modifier to customize the shape of the dialog and give some padding. So here it will be modifier, and first of all you have to do it in order. So we have to clip first of all the shape. That's going to be material theme dot shapes dot large. So if you have missed the order, the shape, it's not going to work. It's going to be always a rectangle. And background color, it's going to be color material theme dot colors dot surface, and the size of this dialog. So the required size, it will be size. Let's give it 80 dp. So that's pretty much it for the dialog. I will add a column representing my my layout. So I'm going to give it a modifier with modifier fill max size, and for a vertical scroll equal remember vertical scroll state, I'm going to assign the background of this composable or this page to material theme plus colors that's on background. And finally, the vertical arrangement or the horizontal alignment, it will be alignment dot center horizontally. So inside the column, first element, it's going to be I'm going to call it a top bar. It's going to represent the like icon, the title of the song with the artist, and the button that's going to allow us to open and close the list of audios. So in the component package, I'm gonna create a new composable. It's gonna be called top bar. So in order to do that layout, I'm going to represent everything by a box. So basically I will have 3 boxes. First box and second box and the third box. I'm going to wrap those 3 boxes in a parent box. Why I have wrapped it to a parent box? In order to center or to allow the boxes to be aligned whether at the start or center or at the end of the box. So for the parent box, it will be modifier fill max width, and I will, of course, as usual, I will add here modifier to make my composable reusable. So for the first box, it will consist of the icon. I'm going to do here leading icon. So leading icon is going to be a composable, and I will need another parameter for the title and for the trailing icon. So the question is why I have opted for a box instead of a row. because in the animation of the leading icon, once I'm going to animate the size of the icon, it will push the position of the title. So that's why I have opted for this approach. So I'm going to rename it here to title. For the first element, it will be placed in the start. So it's going to be modifier, that's modifier, and align, and alignment. So it's going to be start or center start. Okay, so here I will modifier, not modify. I will copy this line, and this will be at the center, and this one, it will be, instead of start, it will be end. So here I think we have to provide, so here I will do leading icon. So if it is not null, it will be invoke. So I have to change this to perhaps you don't have to do a title here, so it will be a nullable value with the same thing here. It's optional. And here, if it's not null, we're going to invoke icon. So I'm going to do here train icon. So that's pretty much it for the top bar. Let's use the top bar in our context. For the first element will be, so first of all, I'm going to add here a modifier to create a space between the top of the top bar, bottom, start, and end padding. So for the top, it's going to be, I'm going to specify for the top 16. For the start and end, 16 dp and 16 dp. I will specify the height for the for this top bar. So the required height, I'm gonna give it 80. Now for the first element, which is the leading icon. So for the leading icon, it's going to be for now an icon, r.drawable. I'm going to do heart outline. I'm gonna give it a modifier of modifier size or required size. Size is gonna be 26 dp. And for the content description, empty string. And for the tint, I'm gonna give it I think it's pink 500. So this is the first element, the title of the top bar, and the trailing icon. So for the title of the top bar, it's gonna be only if we have audio being played. So if state dot selected audio, I will add here, of course, you can do like this, if selected audio equal audio metadata, you can do that, or I'm going to do it with an extension function. And I think it's the time to create the util or the helper file. It's going to be a file. So it's going to be an extension function on audio metadata. I'm going to call it is empty. It's going to give us Boolean. So it will return this different than audio metadata that's empty. Okay, this is I'm going to name it is not empty, not is empty. And in the main activity, I will do here is not empty. Then I can add the text specifying the artist as well as the song. So in order to do that, I will add here an artist value in order to format a little bit the artist name. So basically, if the state selected audio, it's artist, and the artist contains the keyword unknown, I'm going to ignore the case. So in this case, I will provide here an empty string, right? Otherwise, it will be formatted as follow. First of all, I'm going to add here the artist and followed by hyphen. So this is the representation of my artist string. And at the end, I will assign it to a composable text. So the text will be an annotated string. So it will be why I have chosen build annotated string, because I want to represent the artist with a bold font and the rest with a normal font. So with style, span style. So for the font weight here, it's going to be bold. And I will append here the text, which is artist. And the rest, it's going to be a normal text. It will be, so here, song title. I think that we have done here a space. It will be song title. So state that selected audio dot song title. And generally the text will have in color, for its color, it will be material theme dot colors dot on surface. And perhaps the text that contains the artist plus the song title will be a long text. So I'm going to add here overflow, and the style of the whole text, it will be H3. Now we are done with the title. Let's move to the last element, which is the train icon. The train icon, it's going to be represented by an icon button. I'm going to leave on click at the end. And for the content of the icon will be simply an icon. For the painter resource ID, it's going to be r.drawable.up, I think upright, yeah, this is upright from square solid, and an empty string. And I will add here the tint color material theme dot colors dot on surface, not surface but on surface. So now what will happen when we click trailing icon or the icon button? So first of all, we need to see if we have already the granted permission. If we have already the granted permission, we won't load the list of audios. We will show the audios from the loaded list of audios during initialization of the main view model. The other case, we don't have the permissions, so we have to ask the user to give us permissions in order to retrieve the list of MP3 files. So this is what we are going to do. So to do that, I will build a function, a helper function inside the helper class or the helper file to ask the user for the permission. So let's move back to the helper file, and I'm going to add here a function called setup permission, or you can do setup permissions because we are going to ask for multiple permissions. And as a reminder, those are the permissions that I will ask the user to give me or to give us access to, which are the record audio and read external storage. So to ask permission from the user, we need a launcher. This is the new method to do it, because in the old method we do, for example, in the activity. So I think it's an override on activity result permission or something like that. I can't remember the name, but it's deprecated on request permission results. So this is the old method. As you can see here, it's deprecated. So once you get the permissions, you will retrieve the results with this function. So basically, we're not going to do it because it's deprecated. That was the old way. So the new way will be in the help of the manage activity result launcher, and it will be here type array, string, and map of string and boolean. So this is the type. So we're going to need again the list of permissions. So permissions are simply an array of string. So we have to test if permissions, that's all permissions here. I mean with all, with it's the permission. So I'm going to assign here a parameter to be more readable. I'm going to call it permission. So to check if the permission is granted or not, we're going to need a context. So I will add here context parameter. So context compat dot check self permission. As you can see here, check self permissions or check self permission requires a context and the string of the permission. So I'm going to provide context and the permission. So the permission is the parameter permission, and if this permission is granted, so how to do it? It will be package manager dot permission granted. So if all the permissions are granted, we will do here a callback. I'm going to call it on permission or on permissions granted. So otherwise, we will launch the method to ask the user to give us permissions. So it will be launch with the permissions as a parameter. So if the permissions are granted, we will proceed with, in our case, we will show the model sheet. If the permissions or one of the permissions are not granted, we will ask the user to give us the permission for that needed permission. So at the end, I will add a callback function on permission granted or permissions granted. It's going to be nullable or an optional parameter. It will be simply without parameters and void. So, and again, here I will do, so on permissions granted, invoke, and that's pretty much it. So I'm going to use this function. So when clicking on the icon, this train icon, I'm going to see if we have already the granted permissions. If we do have the granted permissions, we won't actually need to load the data because we have already the permissions. And as you can see here in the main view model, if we have already the needed permissions, we're going to be able to load the list of music files during the initialization of the main view model. Otherwise, we will show the user the dialog telling the user, hey, we need this permission in order to access, for example, the microphone or your music folder. So I'm going to set up here to call setup permissions. For the context, it will be context. For the permissions, it's going to be an array of. The first element will be manifest dot permissions or permission dot record audio, and the second one is going to be manifest dot permission dot read external storage. So those are the permissions that I need, and I have to define the launcher. So I'm going to create it afterwards. And finally, I need the callback function to be executed once permissions are granted. What I have to do. So here it's going to be on permissions granted. That's pretty much it. So let's create first of all the launcher. So in order to do that, I'm going to create here in this after state. I'm going to name it. Name it actually whatever you like. I'm gonna name it simply launcher. It will be remember launcher activity for activity result. So as I said before, this is the new way to handle permissions. So I have to provide here the parameter. So the first parameter is going to be the contract. In our case, we want to retrieve or to ask multiple permissions. So it's going to be activity results contract requests multiple permissions. And the second parameter on results, once we have the results, whether granted or not, what we have to do. So I'm going to assign the value launcher to launcher parameter. I'm going to leave the implementation empty for now for the on results because it's a little bit complicated. Not complicated, but so I'm going to leave it at the end. So let's come back to the train icon. So if the permissions are granted, what we have to do, as I said before, I'm going to launch a coroutine scope, because to show the model sheet, you need to call it in context of a coroutine scope. So first of all, if the state dot audios, so if the list of audios is empty, which means that perhaps we didn't have the permission and now we have the permission. If the list is empty, we will call again the method to refresh the list of the audios by calling event, and the event will be audio player load medias, and regardless of empty or not, we're going to show the model sheet. So I'm going to refresh the list of medias only if we have an empty list. And this case of having an empty list, it's going to occur if the execution of our application, the user has, for example, denied one permission. If the user denied one permission, once clicking on the on this button, we will ask the user for that permission. Let's assume that the user accepted that permission. Once clicking again to this on this button, what will happen? We will test if the list is empty. Of course, the list is empty. Why the list is empty? Because during the initialization of our main view model, we are calling the load method, and the load method depends on the permissions. So if the permissions are not granted, the load method will return for us an empty list, because we can't retrieve the metadata if we don't have the permission granted for read external storage. So that's why the list will be empty in the first call. Now, if we have all the permissions needed, we're going to check if we have the audios list. What I mean with we have the audio list of our MP3 files, the list is not empty. We will show the of course, regardless, the model sheet. If the list is empty, which means that we didn't have before the permissions, we will load again to launch again the load medias. So the condition is to keep our mechanism of loading the medias efficient. We're not going to load every time the list of audios every time we click on this icon. So this is the main reason behind this. So I think that's pretty much it for this icon. So now we have to implement the launcher property. So what will happen when we have a result? So the result means the permissions granted or not granted. So we have to test permissions granted or not. So I'm going to call here, add here a parameter called permissions to represent the list of permissions. And I'm going to add here again a value to test if the permissions are granted or not. So if we have only one permission isn't granted, which means the whole operation will fail. So permissions granted, it's a test. So how to test this? I'm going to use it with an elegant way. So permissions dot values, and I'm going to call the function reduce. So the reduce function will assign a parameter accumulator and the next element, and it will add an operation from left to right to the element. So the operation that I need here, it's going to be accumulator and next. So by testing this, we have a Boolean result, and if a permission is not granted, it will return false. Only one. If you have, for example, 3 permissions and one permission is not granted, the whole thing will return for us granted. We can do it only with one single line. If permissions are not granted, this is what we want. We have to show the user another dialog telling the user, hey, we need this permission in order to access, for example, the audio files. So I'm going to call here a function, show permissions rational dialog. You can call it whatever you want. So this is the function that's going to be called to show the user a dialog telling the user you need to grant or you need to give us access to that permission in order to allow us to retrieve the media or the media from your music folder, and we will redirect the user to the settings of the application in order to manually grant access to those permissions. So this is what we are going to do. I'm going to create here in the helper file a new function that's going to allow us to show the dialog. I'm not going to show dialog using Jetpack Compose. I'm going to do it the old way. So show permissions, rational dialog. So in order to show a dialog, it will be shown by the help of the alert dialog object or class that's builder, and we have to specify here the context. So we need, of course, a context of type context. I'm going to pass context in parameter, and we have to set the message to be shown to the user. So the message will be accessible from the outside of our composable. So it will be here. I'm gonna call it dialog text of type string. So the message is gonna be dialog text. The dialog has two buttons, the positive button and the negative button. So once clicking on the positive button, we'll do set positive button. We have to provide here the label of the text of the positive button. It will be resource ID. So after dialog text, I'm going to do here string resource. I'm going to name it OK button resource ID, or icon button text resource ID. It will be of type integer. And we have another button. It's going to be called cancel, which is the negative button text resource ID. So here I will do OK button resource ID. What's happened when we click on this button? So it's going to be a lambda function. So basically the dialog will be as follow. We do need those permissions, OK and cancel. Once clicking on OK, we will redirect the user to the settings of the application in order to grant or to give us access to those permissions. So in order to do that, I will open here an intent. It's going to be of type intent, and it will be settings. So in order to open these settings, we will do settings, action application, detailed settings. Now I need the URI of my application. So how to access the URI of my application? It will be URI that's from parts, and I need here the package as a scheme, and I need, of course, the package name. So the package name of my application, I'm going to add it here as a string. Why I have to add this package name as a string? Because I can't access the package name of my application in this file, so I can access it in the main activity by calling package name. Package name, it's gonna be string. We'll add here package name and null here. Fragment, we don't have any fragments. So in the end, I will add the data to the intent. So intent.data equal URI. If you forgot to add this intent.data, the whole thing won't redirect correctly. In the end, I will do context.start activity to open that settings activity. It will be intent. So that's pretty much it. The whole thing can raise an exception. So in case we have an exception, we'll copy everything to surround it with try catch. In case of an exception, we will show the user an exception telling, or we will show the user another dialog telling that the operation failed or something like that. So alert dialog, builder, context, and set message. This time we don't have to override the OK button. We don't need actually the set positive button, only a simple message. So I'm going to call it here error text. I'm going to add the parameter error text. It's going to be string. So dialog text, error text. So now we have implemented the positive button. Now for the negative button, set negative button. As usual, cancel button text resource ID and a trailing lambda. So here we need actually the first parameter, which is dialog. And the second parameter, we don't need it. So why we need of course, the first parameter, because we need to close, once clicking on the cancel button, we'll close the dialog. So here I'm going to do dialog.dismiss. In the end, we'll call show to show the dialog. So let's come back to the main activity and let's import this function and let's specify the first parameter, which is context. It will be context. Second parameter will be OK button text resource ID. So it will be string dot label OK. We can call it open or something like that, or open settings. I think you better call it open settings, but I'm going to leave it OK for now. The cancel button is going to be r.string.label cancel. The dialog text, we can't access, unfortunately, the resource ID. So I think that we have to do here another parameter. I'm going to call it val dialog text. And another parameter, it will be the error text to use the string resource ID. So it will be string resource, and the ID will be simply the text. I think text. Okay, thanks permissions. I think text permissions will do. Permissions are turned off for playing MP3 files. Please authorize them. So this is my text, and for the error, text error app setting, error occurred while opening settings for this application. So this is the ID, string resource, r.string.this ID. And here it will be dialog text and error text, and the package name by the getter package name. So that's pretty much it. Once we have the permissions, we are going to test if we have all the permissions. Otherwise, we will show this dialog telling the user we need to access your music folder or we need to access your microphone. So now we are done building the top bar. I'm going to add a spacer between the top bar and the rest of the components. So here it will be spacer, modifier, okay, modifier, required height. Height will be 16 dp. We will show the cover image. So the cover image is a nullable. So we have to test if the state and selected audio and cover is not null. What we have to do, we have to show an image. Otherwise, we will show a box as shown in the image. It's going to be a box. I'm going to start with this one because it's easy. So modifier, not easy, but it's convenient. I'm going to specify the height of the box. So it will be required height. And I will specify here the height. I will calculate the height according to the screen height. So I'm going to add a new helper function in the file helper in order to give us the screen height. So it's going to be composable function screen height. It will give us dp. So simply it will return local context dot current dot resource dot display matrix dot height pixels dot dp divided by local density that's current dot density. So I will add here a new value called screen height. So the height of this box, it will be simply, I'm going to take 40%. So screen height time 0.4, and the content alignment, I'm going to center the elements or the icon, which is going to be a card. So content alignment, it will be content alignment dot center. So the element, as I said before, it will be a card. Elevation, I'm going to do it 8 dp. Come on, elevation 8 dp. For the shape, going to do it material theme dot shapes dot large, and the modifier, I'm going to reformat the code, and the modifier will be modifier dot fill max height. I'm going to give it a fraction of the, to fill the max height 0.5, just the half of the height. It will contain an image, so this import image. So painter, it will be painter resource ID equal music. I think it's music something. Okay, musical notes SVG blah blah blah. And by the way, a lot of icons that are used from the SVG repo. And what else? I think I have to add here a modifier because the image is not uniformly represented. So I will add some padding, top, bottom, start, end, in order to make it look like centered. And the content description would be, so the content description, it will be an empty string, and content scale fill height. It won't be deformed because it is an SVG. So I think that's pretty much it for the box. Now let's go back to the image, or the embedded image, which is the easiest one. So painter, instead of doing painter, I'm going to do here bitmap, because we have the bitmap, and the bitmap, it's going to be it, the parameter it. You can add here cover if you would like to make it reusable. So cover, to make it readable, so it will be cover as image bitmap, and the content description, it will be a null content description, okay, empty string. And what else? Content scale, it's gonna be the same thing, content scale, that's crop, not fill height, but crop. In the end, I'm going to add here a modifier in order to clip the shape of the image. So modifier, for the height, I think I'm going to do it the same thing as to look like the box. So it's gonna be screen height, 40% of the screen height. And what else? I have to give it a rounded corner. So shape, material theme, dot shapes, dot large. So I think that's pretty much it for the embedded image. So if the embedded image is not null, I'm going to do an image. Otherwise, it will be a box with those with this image as a default image. I'm going to add here a spacer. So now I have to represent the visualizer. Anyway, I'm going to call the composable stacked bar visualizer. So the stacked bar visualizer will need in parameter the data. So the data basically are the data that we have captured using the visualizer helper. So of type visualizer data. We need the resolution, which is the bar count. How many bars we would like to represent in our visualizer. It will be integer. We need also a modifier in order to make this class or this composable reusable. And I'm going to set here the maximum stack count. The stack, what I mean with stack here in this composable are the small rectangles in this visualizer. So how many small rectangles called stack, how many stack will be in our let's say per bar. So I'm going to do here integer 32. The maximum small rectangles to be represented in a bar will be of 32, and I need to give here a rounded corner or a shape to specify the shape in order just to decorate this composable. So it will be rounded corner, and I'm going to assign the size to 8 dp by default. You can do your own afterwards. And as you can see in the picture, colors of the composable. So I'm going to do it a gradient colors. I'm going to call it bar colors. It will be list of color, and by default I will do here color dot red, color dot yellow, and green. In my case, I didn't choose this color because I have implemented the colors to match the colors that I have chosen in the color file, to match those colors. And as you can see again in the picture, I need the stacked bar background color. In our case, it will be, I think, the color gray or something like that. All right, by default, I'm going to give it color that's gray. So this is the declaration of the composable. We will represent the bar using the composable row. So row, it will be the representation of our bar. I have to calculate the size of my row when the compose have calculated and assigned the size of the whole composable by calling the method onSizeChange. So modifier, it will be modifier onSizeChange, and here I'm going to provide the modifier of our composable. So I need here a new variable. It's going to be called size. So the size will contain the value when the elements first being measured by compose. So remember, and here it will be mutable state of 0. So int size dot 0. So I'm going to import get value, and I will assign the size to it. And here I'm going to represent my composable. So inside the row, I need to calculate the nodes or the bar points or the stacked bar points to be represented as a vector path. If you can see here in my, for example, let's take a drawable. Let's do, for example, backward solid. So the backward solid, this is the path data to be represented as the points to be represented to draw this vector. So this is the same thing that we will do. We have to calculate the nodes to be represented in our vector painter. So I'm going to create a new composable or a helper, private helper function here. It's going to be of type composable, private function. Going to name it calculate stacked bar points. This function is going to give us the list of the points to be represented in the vector painter. So it will be list of a new class or a class that we will create. It's going to be a private one for this composable. It's going to be called points. So I will create this class. You can call it, I'm going to call it here after composable. So as you know, a class or a point is represented. Any point in a 2D space is represented by an X and Y. So I will be doing, I will do here private val point defined. P stands for points, and it will be of type pair, of type float, defining the X and the Y value. So this is a private class. I'm going to do it simply private value class, and I will annotate it with GVM inline class. So we have to set or to write here the getters, and the getters for the X and Y value. So it's going to be function X. It's going to give us points P dot first, and the other, which is Y, it will be second. And I will define here operators that I will need. For example, plus operator or minus times divided. So I will do here operator function plus, and here minus times and divide. So for the first operator, we'll add 2 points to each other. So other, it will be of type point or second. You can call it whatever you want. For the minus, we do the same thing. Other of type point. Here I'm going to do, for example, a point time a factor. So it's going to be a factor of type float, and divide the same thing. So it's going to be a factor of type float. Now the implementation of the first one, it's a point. So we will take the current point. I'm going to add it to add x to other dot x to the value, which is the second one, will be y plus other dot y. Now for the minus operation, with the same thing here, it's going to be point. For the first value, it's going to be x minus other dot x to y minus other dot y. Now for the factor, we will do point x time factor to y time factor. And we will use, for divide, the time function that we have, or times function that we have coded right now. It will be 1 divided by factor. So that's pretty much it for the points that or the operations that we will need to calculate the stacked bar points. What are the data that we will need, of course, to calculate the stacked bar points? We need the resampled data that we have calculated from the class visualizer data, because we have a function called resample, give us an integer array. So the resample or resampled, it will be array or integer array. We need here the viewport height and width. So I'm going to call here viewport. It will be of type float, and width again. We need the bar count of type integer. We need also the maximum stack count, integer. And we need the padding to be applied to the small rectangles, horizontal padding. It's going to be of type float, and vertical padding. So first of all, we have to calculate the bar width. So if we have, for example, 32 bars or 16 bars, we have to assign the value of the bar width according to the viewport width and the bar count. So the bar width, it will be the value of the viewport width, so the width of the composable divided by the bar count. And we're going to retrieve the horizontal padding. So it does make sense. Now for the stack height width padding. So what I mean with stack is simply those small rectangles. So what is the height width padding of that small rectangle? It will be stack height with padding. It will be the viewport, so the viewport height divided by the maximum stack count. It makes sense. We need also the height of the small rectangle. So it's going to be called stack height, which is the stack height with padding that we have calculated, and we will retrieve from it the value of the vertical padding. Next, we have to call the nodes that we will return as a result. So it will be mutable list of, and the value it's going to be point. And in the end, we will do return nodes. So how to calculate those nodes? We'll calculate those nodes from the resampled values. So the resampled values for each element, we will here need actually the index. So the first parameter will be an index, and the second parameter will be the data. So as you know, the rectangle is represented by 4 points. So we have to calculate the points for each rectangle. So that's how we are going to proceed. But before doing that, we have to calculate the stack count. So how many rectangles or small rectangles we have in our composable. And we need to animate the stack count with the function, of course, animate integer as size, because the stack counts are integer, and we want to animate them according to the maximum stack count and the resolution. So I'm going to call here value. It's going to represent the animated stack count by the help of the function animate integer as state. So for the target value, it will be the maximum stack count. If we have, for example, 16 stack, and in our case, we have 32 stack or small rectangles, we will multiply this value, or it will be times, so the data from the resampled value, and we will divide it by 120f. It stands for the resolution, and we will round it to an integer value. So here, round to integer. And we will specify the animation specs. It's going to be tween, and the duration. So I'm going to import tween, and the duration will be, as I said before, the value of the visualizer helper. the duration will be the sampling interval. So it's going to be visualizer helper dot sampling interval. So now we are ready to calculate the nodes for each stack or each small rectangle. It will be for stack index in the range of 0 until stack count dot value. For each element, we're going to calculate the first point on the bottom left, followed by the point on the right corner at the bottom. Next, we will calculate the point at the top right corner and the other point which is on the left top corner. So for the first point will be node plus. So it will be, of course, of type points. And we have to specify the X and the Y value. So for the X, it will be the bar width time the index plus the horizontal padding time the index. So this is the first X. And for the second element, which is Y, it's going to be the viewport height minus stack index time stack height minus the vertical padding time stack index. So for the first point, as I said, it will be the bar width. So if we have calculated the bar width, and we will draw this or store this the bar width according to our index, and we will add to that width the horizontal padding that we will calculate afterwards, and it will be according to the index of our point. So for the Y value, it's going to be as follow: the viewport height minus the stack index, so the according index, time the stack height, because we have calculated the height of each small rectangle, time the corresponding index. We will take the value vertical padding time the corresponding index. So this is the first point. Now I'm going to copy this one. I'm going to change the points according to the points that I want to add to my nodes. So for the second point, which is the right corner at the top of the rectangle. So instead of doing bar width with index, I'm going to increment by 1 the index in order to draw or to represent that point, and that's pretty much it. So I have translated, or I have moved the point by 1. So now for the point in the top right corner, so with the same thing here, instead of index, we will do here index plus 1, and instead of stack index, we will add here 1. So that's pretty much it. For the last one, which is on the left top, on left corner at the top of the small rectangle, here it will be index, but instead of doing stacked index, we will add here plus 1. So now we have calculated the nodes of the small rectangles. Let's come back to the stacked bar visualizer, and here I will add val nodes to be represented, or the represented nodes will be calculate stack or stacked bar points, and I have to provide those parameters. For the resampled, it will be data dot resample, and as a resolution it will be the bar count. So how many bars in our stacked bar visualizer? We need to calculate the viewport width. So here I'm going to call viewport width and height. So viewport height, and here val viewport width. So for the first one, it will be the size that we have calculated during the measurements of the composable. And here I'm going to do width. I'm going to convert it to float. For the second one, it's going to be size, or I can't guess. I have switched them. So I have to do here height and here width to float. I'm going to assign viewport height, viewport width. For the bar count, we have it from the parameters. And for the max stack count, from the parameter as well. for the padding, how to calculate the padding. So the padding, it will be what is the padding that will be applied in horizontal and vertical padding. So I'm going to create here a value called padding. So the padding will be local density, that's current, and we will give it the give it just 1 dp. So the padding has to be of type, okay, let's do here dp to 1 dp dot 2 pixel. So as you can see here, the padding is float to convert the dp to pixel. So it will be here padding and padding. Now we have the available nodes. We can right now draw the rectangle by those available nodes. So I'm going to add here map index, index and point. So if the index reminder of the index, if the reminder of the division index by 4, so why we have chosen 4, because the rectangle have 4 points. We will move to the next point. So it will be path nodes, path node that move, and the point will be point dot x, and the y, it will be point dot y. If we are, for example, on the index 3 or 5, we need to draw the line path node dot line 2 between the point defined by the x and the point defined by the y. So now we are able to link between the first point, the second point, and etc. If we are on the 4th index or the 40th index, so the index that is multiple of 4, we will move to the next point. We can draw the representation by as a vector. So after points here, I will declare here vector painter. Vector painter. It will be remember vector painter, and I have to provide here the parameters. So the parameter, the first parameter is going to be the default width of this vector. It's going to be the viewport width dot dp, and the default height is going to be viewport height dot dp. So I think that this method is deprecated, but I'm going to continue anyway. What else? The viewport height or the viewport width is going to be viewport width. The viewport height is going to be the viewport height. It's those are the same values that you can find here in any vector. This is the height, and this is the viewport height. And this is the viewport width, and this is the width. That's what we are doing right now. I'm going to assign auto mirror effect to false. So here I will do, I don't need actually the parameters, so I'm going to add them with underscore. So inside I'm going to introduce the path composable. So the path data will be the nodes that we have calculated. And I'm going to assign the colors of the vector to a gradient color. So brush dot linear, I'm going to choose here linear, can do your own. For the colors of the linear gradients color are basically the bar colors, and I'm going to specify the offset or the start and the end. So the start will be offset 0 and end will be offset. For the x, it will be 0, and for the y, it will be float. That's positive infinity. So now we have the path of our vector. Finally, we're going to assign this vector, as we do always, to an image, and I will provide here the painter, and the painter will be the vector painter. And the content description will be a content description with an empty string. So this is basically the visualizer, but we need to draw the background of the visualizer as well. So I will add here another composable or a private composable. It's going to be called Stacks Bar Visualizer Background. So the same algorithm that we have done before, it's going to represent the minimum and the maximum of the visualization of the data. I need again the bar count. I need the maximum size count or the maximum stack count. I will need the stack background color and the viewport width, the viewport height, and the horizontal padding and the vertical padding. So with the same thing, I will copy the algorithm that I've done here. Right, so it will be represented by a row. So I'm going to copy the whole thing. So instead of doing here modifier, I'm going to fill the max width. So it's going to be modifier that's fill or max size. So I'm going to get rid of this variables, and for the resampled data, basically is visualizer data that get max processed, and the resolution will be the bar count. And this is the function that we have created as a helper function in order to represent the maximum and the minimum of visualizing or the visualizer data. And for the padding, it will be horizontal padding. For the vertical padding, with the same thing, vertical padding. And here it's going to be with the same thing, index. So we're going to move to the next if the remainder of the division equals 0 by 4, and otherwise we will draw a line. And for the vector painter, it's going to be with the same properties, but instead of colors, instead of fill colors, we will do here solid color, or here I'm going to do here fill. Instead of gradients, it will be a solid color, and color it will be stack bar background color, and it will be represented by an image. So now we have drawn the stack bar visualizer background representing the minimum and the maximum. Let's go back to the stack bar visualizer, and we will put them in a box to represent the background and the foreground. So after basically the path here, after image, I'm going to add here a box. Doing here box import, and it's gonna be modifier equal modifier fill max size, and I will clip this background with shape equal shape. So the shape, as a reminder, it's the shape that we have defined in the composable. Good. So the first element that should be at the bottom, it has to be the visualizer or the stacked bar visualizer background. So stacked bar visualizer background, bar count, maximum stack count, stacked bar background, viewport width, viewport height, and here I think we have called it padding and padding. So this is the first element that should be on the background, and the second element should be on top of that first element. So it will be the image, and this is our stacked visualizer background. So let's come back to the main activity and let's add this composable stacked bar. Okay, I'm going to switch off to change it to private here. Okay, main activity, stacked bar visualizer. So let's start from the beginning. For the modifier, I'm going to add a modifier in order just to create some space between the edges and this stacked bar visualizer. So first of all, I'm going to fill the max width. I'm going to specify the height of this composable, or let's do here, instead of height, required height. And the height that I want is, let's say, 200 dp. And a padding, for the vertical padding, I'm going to give it 4 because I have enough vertical space. And for the horizontal, I'm going to give it 8 dp. Good. For the shape of this composable, it's going to be material theme, shapes that's large. And for the bar count, I'm going to assign it to 32 bars in this visualizer. And the bar colors, it will be list of going to add those colors. You can add your own. Next, I'm going to add the, oh, what's going on? Next, I'm going to add the stack bar background color. So according to the material theme, so it's going to be, if it's a dark theme, I'm going to assign it to the color black, let's say black tree. Black tree actually looks good in the dark theme. Otherwise, it's going to be material theme, that's colors. I'm going to choose here on surface. And because on surface is too dark, I'm going to make it a little bit softer with copy and alpha. I'm going to add it here 0.25. So the last element, it should be the data. So the data that we have captured from the visualizer helper. So let's come back to the main view model and let's see if we have added the data as states. Yes, we have. And the data will be main view model that visualizer data that value, because here it's not a mutable state off, so we're not going to need actually to collect as state. So that's pretty much it for the visualizer. I think that our application is ready to go. Last element that I'm going to add here just briefly, it will be the play button and the fast forward button. So before, of course, running our app, the time bar, I'm going to leave the time bar after testing our application. See here, I'm going just to do here 10. And I'm going to represent those three elements in a row. So it will be modifier, equal modifier, fill maximum width, and padding. So the padding will be gonna do here all 10 dp. And for the horizontal alignment or arrangements, let's do here center. Good. In order not to copy paste code too much, I'm going to add two composables fast button to represent the fast forward and the backward button and forward button. And I'm going to add another composable play pause button to switch between play button and pause button. All right. So inside the composable, let's create the first one. So I'm going to call it, I don't know, fast button. So it's going to be a composable. So this composable is going to be a reusable composable. It will consist simply of an icon button. Let's leave on click at the end, and it will be represented by an icon. So the icon, I'm going to give it painter resource ID, and I'm going to assign to icon resource ID, and the description. Okay, I'm going just to leave the description empty, and modifier, it will be a modifier to assign just a padding to this composable, all equal 8 dp, for example. Let's import 8 dp. And for the tint color, of course, in my app, I don't want to, I want to apply the back button and forward button. If the amount of current position is 5 seconds or 3 seconds, and if I want to get to go back by, for example, to skip back with the amount 5 seconds, so this is not possible. So I will disable this button. So that's why I need here an enable disable state. So enabled. So if it's enabled, I will do here color on surface. If it's disabled, I'm going to do here gray 400. So that's pretty much it. So let's hoist those methods. So on click will be on click. I need enabled. I'm going to call it here enabled, and modifier to make it reusable. So here I will add those methods. So enabled, boolean, and on click, it will be on click. Modifier, it will be modifier, and here the drawable resource icon type integer, and that's pretty much it. So this is the fast button. Let's write the other composable, which is play pause button. So as you can see in the image, it will be represented by a box. I want to make this box look like a button. So I will provide here a modifier. It will be modifier, and the modifier, it will be as always, to make this composable reusable. What is the shape of this modifier, or the shape of this button? So it will be rounded shape. So clip. For the shape, it will be rounded corner, size 100 dp. So you have to do this in the right order. Do not switch the order. So clip. After clipping, we're going to do clickable. And for the clickable method, if the audio is being played, we're going to do pause. If the audio is paused or stop, we will show the pause method, or we can execute the play method. So on play unit, and here on pause. And I'm going to move modifier here. So clickable, and I need to test if we are if the audio is being played or not. So here it will be is playing. Going to move it here, is playing. It will be Boolean. So on click is playing. We will call here on pause. Otherwise, we will call on play. So afterwards, we will add the background of this button, or of this box, color or brush, because we want to do a gradient color. It will be button gradient that we have defined in the color file. And I'm going to align the element, which is the icon, content alignment dot center. If you don't have any selected audio, we will disable this button. If we have selected an audio, we will enable this button. So I will need here enabled state. So at the top, enabled Boolean. So enabled, it will be enabled. So in order to allow this box to be clickable, we have to add here indication, and to solve again the problem of ripple indication. Remember ripple bounded here. Going to do here bounded equal false, and afterward I will set interaction source to mutable interaction source, and don't forget to call remember here. If you don't specify here remember, the box won't be clickable. So mutable interaction source, and finally I will add the role of this clickable box. It will be role.button. So now we have modified, or we have built the box as a button, and inside the box we will add here the icon to be shown. So for the icon, first of all, I'm going to add a modifier just to add a small padding. So padding horizontal, and those values of 16 and 12 that I'm going to add in the padding are calculated because the play icon is not uniformly placed in the center of the box. So I'm going to add some padding in order to make it looks like centered in the box. So horizontal 16 dp, and vertical it will be 12 dp. For the painter resource, I will all right, so for the painter resource gonna be if is plain. What is the icon? It will be r.drawable.pause solid. So of course I have to import our object. So pause solid. Otherwise it will be r.drawable.play solid. And for the content description, empty content description. For the tint color, Here, if it's enabled, to give it looks like to make it like enabled or disabled. So if enabled, we will do material theme dot colors. That's on primary, and on primary it's white. All right, on primary it's white color. Otherwise, it will be gray 300 to give it to make it looks like it's enabled or disabled. So for the first one, which is backward button, it's gonna be a fast button. So as I said before, what is the condition to enable and disable the fast button? I'm going to leave for now the fast button enabled to false, and I'm going to assign the resource icon to drawable and backward solid. And what is the method that's going to be applied on clicking this item? I'm going to leave it empty for now. So this is the first one. This is the second one. It's going to be here forward solid. In between, I will add the play pause button. So for the enabled condition, it will be state that selected audio is not empty. So we have selected an audio from the list of the available MP3 files. For the condition is plain, it will be from state that is plain. I'm going to add here a modifier at the end. So for the modifier, it will be modifier dot padding. Going to add horizontal padding of 26 dp. And let's see if we have added here the modifier in the button. So what is the method that's gonna be applied when clicking on play button? And what is the method that's gonna be applied on pause? So for the on play, you will do main view model that on event, and the event will be audio player event that play. For the pause button with the same thing, it's gonna be main view model on event, and the event will be audio player event that pause. I think that's pretty much it. Let's get rid of the unused imports. I think it's time to launch our application. Hopefully everything is working fine. Luckily, we don't have any error in the compilation. So the application is being installed. So here is the splash screen. Right now we don't have any permissions. So the application won't be able to, oh, here we go again. I don't know why I have done this. I'm going to change this background to something else. What we have done here actually. What is the background? All right. Okay. The content here. Okay, not on background, but I think it's background. Let's run again the application. So splash screen. There's no medias for now because we didn't load anything. So this is the right background. So we have the button, like button. We have the button that's gonna allow us to open the media files. And we have the embedded image, the default embedded image, if the audio doesn't have any embedded image. And as you can see, we have represented the stacks bar visualizer with the maximum and the minimum values that can reach top and the bottom of the visualization of the data, as well as play pause button and the other button. So we didn't introduce the time bar for now because it's gonna be after testing this our application. Now let's click the button to open the bottom sheet. As you can see here, the device is asking us to allow access to media file. Let's say, for example, allow, and let's say, for example, the other headphone record audio, deny. So if we denied one of those permissions, all the permissions or one of them at least, it will show us this particular message. Permissions are turned off for playing MP3 files. Please authorize them. So if I click, for example, cancel, nothing is going to happen. It's going to give us again the record. Let's say, for example, deny. And let's go, or let's click Open App Settings. Open App Settings, it's going to redirect us to our application. So this is the settings of our app. And let's click on Permissions. Once clicking on Permissions, as you can notice here, we have the denied permissions with only one permission, which is microphone. I'm going to manually allow access. I'm going to hit allow, previous, and let's go back to our app. Now we can load again. That's why we have chosen here in the, what is the button first of all? Now we are in this condition. It's going to test if the audios are empty. Of course, the audios are empty, so it's going to refresh the medias, right? So I'm going to select the first audio. So as you can see here in the real time, you can see the visualizer trying to represent the waveform, and I think that's everything's working fine. Let's test, for example, play pause button. So we can pause the playback. Let's play again. And as you can see, we can pause and stop in the meantime the visualizer. Let's choose another song that has, as you can see here, this is the song that's being played, represented and highlighted. Let's click space that has, I think it has the embedded image. So here is the embedded image. So congratulations, we have successfully implemented those functionalities. Now we're going to implement the TimeBar as well as the adding the song to the list of liked songs. So now we have to implement the TimeBar composable. So I'm going to create a new composable in component folder or components package. I'm going to call it TimeBar. A TimeBar consists of text representing the current position, a slider, and another text representing the duration of the MP3 file. So it's going to be here a row, and it will occupy, or I'm going to just do here a modifier with a modifier, and I'm going to add the modifier in order to make this composable reusable. So modifier of type modifier equal modifier. And for the vertical alignment, I'm going to align the elements center vertically. So as I said before, it consists of a text and another text, and in between a slider. So the slider composable will be the timeline of our MP3 file. So let's implement first of all the text. So the text will be the current position, and the current position will be we'll get the current position from the main view model. So in the main view model, we can access the current position as follow. Let's see here. Let's say, for example, play method. We can access the current position by doing player.current position, and current position, the type of the current position is integer. So I'm going to create here a parameter. I'm going to call it current position. It's going to be integer, and I have to convert the current position because current position, it's going to be in the format of millisecond. I have to convert the millisecond format to a representable string. So I'm going to head to the helper file, or helper, yes, the helper file. I'm going to create a function. I'm going to call it milliseconds to time string, milliseconds of type integer, and it will return a string. So I'm going to declare here a variable called result, representing the final string, and I will return this in the end. I will return this result parameter or result variable. So I need here to calculate the hours. So the hours will be as follow: the milliseconds divided by the value of 1000 to convert to second, by 60 to convert it to minutes, and by another 60 to convert it to hours. So this is hours, and for the minutes it will be of course milliseconds. It will be of course the remainder of the division, milliseconds modulo the conversion of 60 and another 60 from seconds to minutes to hours, and we're going to take the remainder of this operation and we will divide it by conversion again from the millisecond to seconds, and from the seconds to minutes, and another value, it's going to be called seconds. It will be again the milliseconds, the remainder of the division of the conversion from milliseconds to minute to hours, and with another reminder of the division of the conversion from seconds or milliseconds to seconds to minutes. And in the end, it will be divided by 1000. 1000 represents the seconds, all right? So if the hours is more than 0, we will add hours in the final string. So it will be result equal hours. We'll do here $, so to add the hours to the final result. And we will format here the seconds. So I'm going to call here another variable or value. So it's going to be variable seconds string. So for the seconds string, it will be second string equal. So if the seconds are less than 10, we will put here 0, and next to the 0 I will do here the seconds. It's like 0 and 01, 02, 03, 04, etc. until the 9th number, or until 9, and otherwise we will put here seconds. So it's bigger or equal than 0, it will be the number without 0, and if it's less than 10, it will be 0 plus that number, and the final result will be the old result, or the old result. What I mean with this, it's the result with hours, and I'm going to add here minutes and seconds string. So I think there is no need actually for this parentheses here. So let's come back to the composable, and I'm going to do here milliseconds to time string, and I will provide here the milliseconds. So the milliseconds, it will be the current position. For the style, it will be material theme caption, and color will be on surface. So with the same thing, instead of doing current position, it's gonna be duration. Going to call here parameter duration. And now we are going to implement the slider. So first of all, I'm going to add a modifier to the slider. So I'm going just to add a padding HDP to space between the two elements, so the current position and the duration. So here, not padding value, but horizontal HDP. And I'm going to fill the max width fraction of 0.9, so 90%. And I think that's pretty much it. So the slider has the parameter value. So the value of the current position. So it's going to be current position dot float or to float. So what is the method that's going to be called whenever the value change? So it will be on a value change. We're going to hoist this method. I'm going to call it with the same thing on value change. I'm going to pass, because the on value change has in parameter it as float, meaning the current position. So I'm going to pass it as a value, or I'm going just for readability purposes, I'm going just to leave it like this. And what else? For the value change, okay, I'm going to do it here explicitly. Value, I'm going to pass value here just for readability purposes. And value range, so what is the minimum amount or the minimum value and the maximum value of this slider? So it will begin from the value 0 until the duration. I'm going to convert it to float. So we need here a method. It's going to be on value change and takes in parameter float without a return type. So this is our slider. Let's use the slider in the main activity. So between the visualizer and the row of buttons, I'm going to add slider. So this is the buttons and this is the visualizer. So in between, I'm going to add here another spacer with the same amount, and I'm going to add TimeBar. We need actually a state to store for us the current position. So I'm going to create a state in the file MediaPlayer state. I'm going to call it current position. It's going to be of type, as we said before, the TimeBar is going to be integer. So the current position will be provided by the state.current position. And what is the method that's going to be called when on value change? I'm going to call it here position as a parameter. And the duration, so how to access the duration of the MP3 files, simply state.selected audio, and we got the duration from the metadata. So the method that's going to be applied whenever we change the position of the slider, it's simply the method that we have declared here called seek. So we're going to position the MediaPlayer object to. So I think there is a problem here. What's going on? I have to initialize the current position here. Where is the events or states equal 0? So as I said before, the method seek is going to place the current position of the playback to that current position from the slider. So I'm going to basically use the method seek. So here I'm going to do main view model dot on event, and the event will be audio player event dot seek, and I will provide in parameter position equal the position, and that's pretty much it. We have declared the TimeBar, but unfortunately the current position won't be updated. If you launch now the application, the current position will be always in the 0. So we have to find a mechanism to allow us to update the current position according to the playback. So let's move to the main view model. In order to do that, we will use a handler that's going to be the main looper. So in other words, we will update the current position periodically with a looper. So it will be a private value handler. So it will be handler and looper that's get main looper. So the handler is going to allow us to execute a piece of code or execute an instruction periodically while specifying the amount of duration. On the play method, we're going to update the current position. So here we have set is playing equal true, start, and we capture the data. So directly after capturing the data, I'm going to add here a handler, and I will do post delayed, and I have to provide here a runnable object. So I'm going to do here object, and it will be of type runnable, and I have to override the methods. Only one method, which is run. I will do here for the delay 0. So inside the run object, I will change the state of my current position to state.copy, and current position, it will be player, and I'm going to force the, if it's not null, of course, I'm going to get the current position. And afterwards, I will do here handler and post delayed. I will specify the runnable, it's the current object, and here the duration, it's gonna be 1 second. So this block is going to raise an exception, so I'm going to surround it with try catch exception. Okay, exception of type exception. In case there is any exception, I'm going to set the current position to 0. State copy current position equal 0. If everything is working perfectly fine, we will change the current duration or the current position to the current position of the media player. So that's pretty much it. This is how we update the current position. So after doing stop, I'm going to add here, I'm going to change the current position to 0, indicating that we have stopped the playback. If you have noticed, in any media player, after the playback is done, so when reaching the current position equal the duration, of course we have to stop the playback. So there is a listener for that purpose. So it's going to be set on completion listener. So this method is going to be called when the media player is done reading the MP3 file. So in this case, I'm going to do here pause. So I think that's pretty much it. So we are ready to implement the rest of the application. Now we are able to update the current position in real time. So the things that we did not implement here are fast backward and fast forward. The first thing, I'm going to specify the method that's going to be called to set back the position with 5 seconds. So it will be main view model that on event, and event, it will be event.seek audio player event.seek, and I have to provide here the position. So the position will be the current position minus, I'm going to call it a step. So the step, it will be whatever you want, 5 seconds, 3 seconds, just do the steps that you like. So I'm going to create here function. So I think the helper class is going to be in the util package. So I'm going to refactor this, and inside the util package, I'm going to create another file. It's going to be called constant. So here I'm going to define constant val. I'm going to call it forward, backward, step. So I'm going to do it here 5 seconds. So let's come back to the main activity, and here I will do state current position minus forward backward step. I'm going to, or we can here just to, instead of converting it to float, where is constant file, add here f. That's pretty much it. So this is the method that's going to be applied. So now we are able to move back to set the current position back with 5 seconds. So what is the current or the condition to disable or enable this button? So for this tutorial, I'm going to enable the button if only the current position is more than the forward step. If the current position is more than the forward backward step, the fast button is going to be enabled. So for the fast forward, let's do here first of all the method that's going to be applied. So it will be main view model that's on event, and the event will be audio player event. seek, and the position will be, so instead of doing current position minus forward backward step, it will be state current position plus the forward backward step. Now the condition to be applied to allow disable or enable the button, so it's gonna be enabled only if the states, that's current position, is less than the states that selected audio. So if the duration of the selected audio minus that forward backward amount step is bigger than the current position. So I think that's pretty much it for this section. We have to launch the application and see if it's working correctly. So I'm going to run the app. If everything is working fine, we're going to implement the last tutorial, or the last objective, which is how to deal with shared preferences in a small example. Okay, we have a problem here. So instead of doing this, so this is an error that I forgot to correct. The refactoring did not do its job correctly, so I'm going to relaunch the app. So the application is being installed, splash screen. You can see here the slider. So nothing happened because there is no current position and there is no range. So let's see, for example, this track, Fun Life. You can see the button is disabled now. Once reaching more than 5 seconds, it will be enabled. So we can do the operation of fast forward and backward with 5 seconds. We can even position the current position using the slider. And let's see what's gonna happen when we reach the end of the when we reach the duration. So the button is disabled, and that's pretty much it. If we click again on the play button, it's going to play again the track. And let's position it to the end of the current position. And let's change, for example, let's select this track. So I think everything is working fine. You can do that with 13, and let's go back with 5 seconds. So everything is working fine. The next thing that we will implement is the like button. So in other words, we will add songs to our favorite songs. So I'm going to pause the music. So as I said before, if you want to deal with saving small data, or you don't need actually relational database, you can use, or you have to use in this case as a solution, you can use shared preferences. So in the audio package, I'm going to add here another class. I'm going to call it user preferences. So how to declare the user preferences, or how to create, let's say, a database. We're going to call it a data store using the shared preferences. First of all, we have to define the data store, the name of our data store. So it's going to be inside a companion object. So I'm going to call it private val. So context that data store. It will be of type data store and of type preferences. So this is how to declare your data store, preferences, data store, and I'm going to specify here the name of our data store. So I'm going to call it here private const val. So I'm going to name it headphone. So as a name, it will be headphone player, and here it's going to be headphone player preferences. Then we have to specify it's like, think of it as the table name. So it's not the table name, but it's gonna be the key in this case. So the key will be declared as, let's say, we want to save here liked songs or favorite songs. I'm gonna call it val. Let's just name it favorite songs, and this is a key. So I'm gonna call it key. It will be a string in this case. We're going to save the favorite songs in a format of a JSON string. So it will be here favorite songs. You can do it favorite songs or liked songs. I'm going just to leave it favorite songs. So if you want to add another key, you can just do, or let's think of it again as a table. So the key to be saved to contain the data. So you can add here another key. Let's say you want to add settings. You can add here settings. This is how to do it. So those are the keys that we can access in order to save or read the data from. So I'm going to delete this one. So the first method that I will need, or the first parameter, or the first field, it's gonna be the favorite song. So I'm going to call here private val favorite songs, and I want to have the updates in real time. So it's gonna be flow of type string, because we have declared here string preferences key, and it's gonna be, let's import flow. So I'm gonna specify here a getter. So in order to access the data of that key, I need actually a context. We have provided, or we have installed, or we have prepared the dependency injection. So Hilt knows how to inject the application context. So I'm going to add here inject constructor and application context val context of type context. So for the getter of this value, it's going to be context dot data store and data, and I have to retrieve the key that I want. So I want here in my case the favorite songs. If we have, for example, another field as settings, for example, instead of favorite songs, I'm going to add here another getter or a field or a member to specify the data stored in that specific key. All right, so it's going to be, as you can see here, it refers to preferences. So it will be preferences as a parameter. And I'm going to do preferences because it's an array. And I have to access the array with the preferences key. I'm going to do here preferences or favorite songs key. So now we are able to get the favorite songs in the format of string. So, but in our application, we don't want, of course, to deal with the conversions from string to list and vice versa. We're going to implement this in this user preferences. So for this is the private member. Now I have to set a public member to be exposed outside the user preferences. So it's gonna be favorite songs. I want it to be a flow. This time it will be list of long. List of long refers to the IDs of the songs. So I'm going to save in the shared preferences the IDs of the favorite songs. So it's gonna be flow. I'm going to construct right now the flow. I will get the data obviously from the favorite songs. I'm going to collect to emit the data, but I need to convert the data from string to list long. That's why I have chosen to convert the data using the JSON converter. We have imported the library JSON, so I'm going to declare here a variable or local variable private val JSON of type JSON. So it's going to be directly JSON. We're going to convert this data from list to string and vice versa, as we did before when we have declared the type converter in the database. So the first method that I'm going to do here is from string to list. So I'm going to call it private function from string to list long. So the source, it's gonna be string, and the result, it's gonna be list of long. So directly it will return. The operation is going, it might raise an exception of type JSON syntax exception. So it will be try catch exception of type JSON syntax exception. In case we have an exception, I'm going to return here empty list. Otherwise, we will do here JSON dot from JSON, and the source is the string, and the object for the conversion, it will be type token, and the type is list of long, parentheses, curly braces, dot type. So inside collect, I'm going to add the conversion. So I will emit the value from string to list long, and string, it will be, I'm going to name it here JSON or something like that. It's gonna be JSON. If it's not null, I'm going to return an empty formatted JSON string. Now we have the list of favorite songs. I need to add a method here in order to save or to add a song to the favorite song or delete a song from the favorite songs. So I will add a function. It's gonna be suspending function. I'm gonna call it like or not song. It will take in parameter an ID of type long. So in order to save or update, generally speaking, add a record or update a record in data store, simply use context.datastore, and I will edit the data. So here's gonna be preferences, and I can do here, if you want to save the value, it will be preferences dot, we call it favorite songs key, and I have to assign the value, but this is not what we want in this app. So I have to get, first of all, the songs. So the songs will be favorite songs, and I'm going to get the first snapshot, and I will cast it to mutable list. So this is the songs, and I will test if the songs contains the element ID. In this case, what I have to do, I will remove from the list of songs the ID. So in order to delete the favorite song. Otherwise, I will add to the list of songs the element ID. And finally, I have to convert this list of songs to a string. So I'm going to write another function. It's going to convert from list long to string. So it's going to be from list long to string. It will take in parameter list long, and it will give us a string. So instead of doing from JSON, we will do here to JSON. For the source, it's going to be list long, and for the type token, it's going to be list of long. And if there is any exception during the conversion, it will return an empty formatted string or an empty formatted JSON string. So here, what we have to do, we will do preferences. So we are inside the edit. So preferences, favorite songs key equal the new string, which is from list long to string, and the list long will be songs. So that's pretty much it. We are now able to read the data, which are favorite songs, as flow, and we can add or delete a song by this simple algorithm. I'm going to get the songs or the first snapshot, and I'm going to test if the ID belongs to the songs. I'm going to remove it. Otherwise, I'm going to add it, and I will convert from string to from a list to a JSON string. I'm going to update the previous value to this new value. So that's pretty much it for the shared preferences. It's pretty simple. So I'm going to add the two functions to the list of the methods in our interface in the domain layer. So let's go back to the domain layer, repository. I will add the first method. I'm going to call it like or not song. So from the shared preferences, I'm going to copy this one. So this is the first method. The second one, it will give us the favorite songs, or it's gonna give us the favorite songs. Get favorite songs. It will give us flow of list of long. As I said, it will represent the IDs. Good. Let's come back to the implementation inside under the repository under data layer, and let's implement those two members. I will need here an instance of the user preferences. So it's going to be private val user preferences. For the method like or not, I'm going to execute it in the context of a coroutine scope, dispatchers.input output, and I will call user preferences that like or not, and the ID equal ID. For the get favorite songs, it's pretty simple. It will be return user preferences favorite songs. So now let's go back to the main view model, and I will add, before going or implementing anything in the main view model, I will add those two functions, or one function actually, to the list of my events. So the audio player event, it's gonna be a data class. So I'm too lazy to do it. I'm going to copy this one. So it will be like or not. So it will be a data class, like or not, capitalized, val ID of type audio player event. So I'm going to implement this function first of all in the main view model. So I will create here a private function. So it's going to be like or not, and I will launch a coroutine scope. Inside the coroutine scope, I will do repository dot like or not, and the ID equal ID. And I will add this function to on event method. So is audio player event dot like or not song. It will be like or not song with ID equal event dot ID. So we are done basically with the main view model. So let's come back to the main activity, and I will change this heart button, or this icon button. Okay, where is the icon button? Top bar. It's confusing. This is getting bigger. So top bar. So instead of this heart button, I will do here a composable. I'm gonna call it like button. So this button is going to have an animation. First of all, let's build the composable, then we will add to it an animation. So this composable, it's going to be an icon, paint resource, and depending on whether the song belongs to the favorite songs or not, I'm going to add here a parameter called isFavorite. It's going to be Boolean. So if it's favorite, we will add r.drawable. Let's import r. I'm going to choose, in this case, the solid icon, so heart solid. Otherwise, it will be r.drawable.heart outlined. For the content description, it's going to be an empty string. For the tint color, again, we have to specify here, because if there is no selected audio file, this button, it has to be disabled. So I'm going to add here another parameter called enabled Boolean. So if the icon is enabled, what is the tint color? It's gonna be pink 500. Otherwise, it will be material theme colors that's on surface. Good. Now I'm going to switch this or to transform this icon as a button. by the help of modifier. Okay, I'm going to do here again modifier as a parameter in order to make this composable reusable. So modifier, you have to follow the order of clipping first of all the icon in order to maintain the ripple effect, then add some padding in order to not limit the ripple effect to a small size, and then introduce the clickable function. So that's what I'm going to do here. First of all, I'm going to clip, even it's not, if it's an icon, there is no shape or something, but the ripple effect will be deformed. It's not going to be rounded. So that's why I have to clip this, the shape of this icon to rounded corner. I'm going to do size here 100 dp. I think even 50 will do the job. And I'm going to do a padding all equal 8. Then clickable. So for clickable, first of all, I will add enabled in order to enable or disable this icon as a button. Second of all, I have to, in order to maintain the ripple effect, I have to set here the indication to remember ripple, and I will do bounded equal false. Then add interaction source, and don't forget, as I said before, to add here remember, otherwise it won't be clickable. Import remember and mutable or mutable interaction source. Then I will specify the role of this icon as a button, then on click. So what's happened when we click on this icon? I'm going to create here another method called onClickUnit, and I will do here onClick. So I don't want the icon to be just a still icon. I want to add some animations. So if you are interested, let me know about a course of animations in Jetpack Compose in the comments section below. I'm going to add the animation val transition. So this is the new way to add keyframe transition. So I'm going to call it transition. It will be update transition, and I have to specify the target state. So the target state basically is favorite, and I have to specify here the label. So even it's for us, it's not useful. I'm going to call it transition. Next, I have to specify the keyframe in order to make that animation. So what are the keyframes? Basically, it will be, the heart is going to be bigger than the initial size at a given frame, and it has to shrink to initial size. So I'm going to create here size by transition as we have created, and I'm going to animate the size as dp because we care about dp in this case. For the first parameter, we should provide here the transition spec. You can choose, so you can choose from the transition specs, tween, spraying, etc. or keyframes. In our case, I'm going to use keyframes, and I have to provide here again the label. It's going to be size. So for the keyframe, I will specify first of all the duration. So the duration or the whole duration of the animation is going to be 500 milliseconds. And in the frame, for example, 250, what I will do, I will change the button size, and I'm going to increase the button size with a given value. So in order to do that, I will create here another optional parameter. I'm going to call it button size of type dp. I'm going to give it 626 in order to give the initial size of the button. All right, so at the frame position 250 milliseconds, what's going to happen to the size of the button? I will do here button size 26. I'm going to add a small value to it, for example 10 dp, and width linear. I'm going to do here linear out slow ease in. With the same thing, for example, let's say at the frame in the 400 milliseconds, what we will do, it will be back to the normal initial size with linear out slow in easing. Okay, so after the label, we have to specify the target value by state. So I'm gonna call here the state, and the state refers to whether is favorite or not. It's a Boolean value. So if it's a favorite, in our case called state, if it's favorite, it's gonna be button size. Otherwise, it's gonna be button size. Doesn't matter if it's a favorite or not. So this is the animation of our of the size of the button. Finally, I will do after clickable size, and I'm going to assign the size of the button to the animated size. But in the application, I don't want to every time I enter the composition state, I will launch this animation. So I'm going to, this is just a workaround if you want. I'm going to create a value that's going to test for us if we should animate the size or not. So it's going to be val should be animated equal, remember, mutable state of, and the initial value it's going to be false. What is the desired effect, or what's the desired result? Once clicking on this icon, then we have to launch the animation. Otherwise, the animation shouldn't be launched. So that's pretty much it. So on click, I will do should be animated dot value equal true. And as a condition, I will do, instead of size as this, if should be animated that value, then I will do size, or the animated size. You can add here just for readability purposes, animated size. So I'm going to change this one, animated size. And in case it should be animated, it will be animated size. Otherwise, it will be button size. So that's pretty much it for the animation of our icon. So let's go back to the main activity. And here I have to specify the like button. So to know that this song is belongs to the list of favorite songs or not, we need actually another state. So the other state is going to contain the list of favorite songs. So here I'm going to add another state called favorite songs. And by default, it's going to be an empty list. All right, so let's come back to the main view model, and we have to store the list of favorite songs. So the ideal place to call or to store the favorite songs is the method load medias. So pretty much after entering the loading state and after getting the list of MP3 files, directly I will add, or I will change the state of the favorite songs to state that's copy. I'm going to remove this line first of all, because I have to separate them. So here I'm going to add the list of audios to audios. And afterwards, I will call the repository that gets favorite songs. And here I'm going to collect the result of the flow. So it's going to be here, instead of S for readability purposes, favorite songs. I will do here state equal state dot copy. Then I will do here favorite songs equal favorite songs. And in the end, we have to set loading to false. So is loading equal false. So that's pretty much it for the load medias. Now we have the list of the favorite songs. So how to know whether it's is favorite or not, simply it will be state dot favorite songs if it contains the state, in other words, the selected ID or the selected audio ID, song ID, which means is favorite. Otherwise, it doesn't belong to the favorite songs. Now for the enabled method or the enabled parameter, it's simply obvious. State that selected audio if the selected audio is not empty, as usual. Now for the method onClick, what's going to happen when clicking the method? We will choose main view model, and on events, and the event that we have to call is audio player events that like or not song, and we have to provide here the ID, which is state that selected audio that song ID. So that's pretty much it. Let's test our application and let's see what's gonna happen. So the application is being installed. We have the splash screen. Okay, so first of all, I'm going to choose, for example, this track. All right, I'm going to add the track to the favorite songs. So as you can see, let's do pause here. This is the animation. Let's remove it from the list of favorite songs. Good. I'm going to add it. Let's click another track. So let's like the song. Let's move to another track. All right. So let's come back to that this song. So I think it's working fine. Now let's see if the application or all the states survive the configuration change. I'm rotating right now the screen. So everything working fine, even the position. Let's rotate back the screen. Now I want to see what the application looks like in dark theme. So here's the dark theme. So I think it looks fine in the dark theme. That's pretty much it. So I'm going to pause the playback. So this is how to implement a MediaPlayer or an MP3 player using Jetpack Compose MVVM and Clean Architecture with MediaPlayer. You have learned in this tutorial how to do basic operations such as play, pause, stop, and MP3 player. You have learned how to visualize the raw waveform in a composable, and we have called this composable visualizer. And by the help of the visualizer class, you have learned how to retrieve the metadata from an MP3 file, and you have learned how to save small data or data that are not complex using the shared preferences. I hope you liked the video. It's been a pleasure sharing with you my knowledge. Take care of yourselves and bye-bye.